ठीक है, चेक करते हैं एक बार।
हाँ सर देखिए बस आएगा। सरप्राइज दैट।
ठीक है, स्टार्ट हो गया।
हो गया। ठीक है सर।
ओके।
हो गया। हाँ
ठीक है। All right, so hello, and welcome everybody on this beautiful platform of PW. This is your physics mentor Gaurav Tiwari, and today, my dear kids, we are going to start a new series altogether. And the name of the series is Endgame, right? So, what are we planning to do with this series? Let me first tell you. We are going to discuss 50 questions from various chapters, right, in specific segments in this particular series, right? So, what is the aim of this series? With the help of this series, you will understand what kind of questions are asked in the NEET exam, because we have picked all the questions from the previous year exams. So you will have an idea. You will get an idea about what is the difficulty level of the exam and what are the important topics, what is the current trend of those chapters in the exam, right? Okay. So we can start right away, but before we start with anything else, right, just give me a quick yes so that I get an idea that my audio and video is very clear, right? So just give me a quick yes, right? So yeah, so this particular video is going to be filled with quizzes. So the best way to attend this lecture is pick up your notebook, right, and start solving the questions with me, right? You will get the practice of around 6 to 7 chapters in this particular video itself, in this particular class itself, right? Okay. So just pick up your notebook. I will show you a quiz, like I'll show you a question, then I will show you the quiz, and then we will discuss the concept behind the question, then we will analyze the trend, right? So we are not very much concerned about how to solve it, because at this moment I cannot teach you that you solve how to solve 7 different chapters in like 3 hours, right? But the trend analysis and how to approach the question, like those things we can discuss, like conceptual things we can discuss for sure, right? So if I'm clearly audible and visible, just give me a quick yes and we will start right away. Okay. Hi Priya, hi Sajal, hi Anchara, hi Vishnu. All right. So let's start right away. So I'll be showing you some questions and then you have to solve it, right? I'll give you some time to solve as well, right? So this is about basic physics and core mechanics. So what are the chapters that will be included in it? So we will include units and measurements, right? From here, 4 easy marks you can expect, right? Then kinematics, 4 marks to 8 marks you can expect from kinematics. Then laws of motion, recent years, in recent years what kind of questions are asked in laws of motion? Again, 4 to 8 marks are expected from this chapter. Work energy power, generally 2 questions they ask from this chapter as well, so again 8 marks or so you can expect from this chapter. Circular motion, again sometimes they ask you one question which is easy, sometimes they don't ask, so generally 4 marks you can expect from circular motion. Gravitation, again you will get one question for sure, so 4 marks again. Rotation, you will get 2 questions or 1 question, so 4 marks or 8 marks. My dear kids, if you are weak in rotation, right, at this very moment, you don't have to start the rotation. I will suggest you go with the formulas, cover only the basics, right, and see if the formula based questions comes up, you can solve it. And at last we will solve few questions of center of mass. Generally one question is asked from here. So with this particular series, with this particular class only, with this class only, you can expect around 32 marks. You will get an analysis of 32 marks, right, in the physics section, right? So you see that around 28 to 32 marks, around 28 to 32 marks you can expect from the analysis of this particular thing. You will get an idea about what is the recent trend and what are the recent questions. My dear kids, I have picked some questions that you have to leave. Okay, I will show you what kind of questions you can see. Even if you know it, you don't have to attempt it, right? Just go through the entire paper and then mark those questions, right, for the end. I have picked 2 or 3 questions like those also, so that I can give you an idea about that. Recently some very lengthy questions are also asked, so I will tell you like how to approach them as well, right? So let's start right away. Okay, let's start right away. The first part is units and measurement. So some questions from units and measurement will be there, right? Total 50 questions will be covered in this class. I will show you the question, I will give you the quiz, right? Throughout the class, you can attempt it, right? I'll give you 1 minute to 2 minutes for each question, and then we will discuss the concept behind each question, right? Okay. So if you guys are ready, just give me a quick yes, and we will start right away with the first thing, units and measurement, right? So we are going getting ready with the 4 marks, okay? All right. Now, if you talk about this particular chapter, generally the concept of error analysis, right? Error analysis is asked multiple times, right? Significant figures, significant figures, right, is asked multiple times. And principle of homogeneity, that is also very, very important. So 3 concepts are very important from this chapter, right? And you can expect, like in the recent years, they are asking the questions from these 3 concepts. So if you have not covered any of these things perfectly, it is a time where you can definitely go through these 3 concepts on the like primary basis. Okay, so let's start with the first question. A physical quantity P is related to 4 observations A, B, C, and D, follow like with this particular relation. So P is this, right? The percentage error of measurement in A, B, C, and D is in measurement of A, 1% error is happening, in B, 3% error is happening, in C, 2% error is happening, and in D, 4% error is happening, right? So you are measuring 4 quantities, and in every one you are making an error. So of course, P depends on all of them. So if all of them have an error, right, so the result will also have some error, okay? So the percentage error in the quantity P is going to be, so what will be your answer? This is asked in 2025. So as I said, questions on error analysis, significant figure, right, and principle of homogeneity, they are very, very important. Don't miss it. So here I am going to start the quiz, right? So this is slightly lengthy question, so I will give you 90 seconds to solve it, and I'll tell you again how to attempt the paper, like physics paper. Keep it for the last. If physics is not your strongest subject, keep it for the last, right? And make an approach that I have to like save at least 60 minutes, that is 1 hour for physics only, right? In 2 hours I have to solve everything else because that is mostly theoretical, and I have to keep 1 hour at last for physics only. Then only you can score maximum in this part. So with that, let's start the first thing. This is a single choice, so we can start the poll, and you can answer it. Okay, so you just answer it in your comment section, right? Just answer it in your comment section. No problem, Rahul. Okay, just answer it in the comment section, right? And we can start from there. Okay, all right. Hello, hello. Okay, so the quantity P is A cube B square upon C under root D, right? So what will be the error in the measurement of P? So you see that whatever quantity has some power, that will affect the final result, like that will have maximum impact in the final result. So how will you write it? Delta P upon P, percentage error. So delta P upon P into 100 is 3 times delta A upon A into 100 plus 2 times delta B upon B into 100 plus 1 time delta C upon C into 100 and plus half time delta D upon D into 100, right? So just try to solve it and you will get the answer. Okay, just try to solve it and you will get the answer. Okay, all right. I hope the idea is very, very clear. Simple kind of problem is there, right? And you can expect this kind of question also in your NEET exam, right? Okay, so just a second. Yeah, very good. Malika is saying A, please sir teach concept plus question. Concept understanding at this particular moment is very difficult, but we'll be doing some of that in one more course that we are going to launch soon. So there we are going to discuss concept. These sessions you can treat as practice, right? You can treat as mock test, okay? Live mock test, okay? So you can solve the questions with me and then at the end we will be solving it together, right? Okay. All right. So let's see. Right. Okay, so this one, Malika Arjun gave the answer first, right? So after that, you see that option A was coming out as the right answer. So the correct idea, as I have already told you how to solve it, this is the given quantity, and in all the measurements, you are making some error. So what will be the final error? Delta P upon P into 100 is 3 times delta A upon A into 100. 100 is taken out, right? 2 times delta B upon B into 100, 2 times delta B upon B into 100, 100 is taken out. 1 times delta C upon C into 100, 100 is taken out, and half, because under root is there, half times delta D upon D into 100, right? Just add them up. In each one of them, delta A upon A into 100 is given 1%, then it is given 3%, it is given 2%, and it is given 4%. So whatever those values are, just write it down, and 13% is the final answer. Look at one more question. The question is saying that a metal wire has a mass 0.4 plus minus 0.002 grams, right? This is the mass of metal wire. Radius of the metal wire is this, and the length of the metal wire is this. The maximum possible percentage error in the measurement of density will be, maximum possible error in the measurement of density will be, right? Teach this question. So if you want to understand, if you want to understand this particular question, Rudra is saying that, so you see that whenever a quantity is like this, if A is equals to A to the power N, B to the power M upon C to the power K, right? See that, Rahul, if you are making an error while measuring A, B and C, all of them, right? So all those errors will reflect in the result, okay? You are making an error in the measurement of A, you are making an error in the measurement of B, you are making an error in the measurement of C, right? So all the errors, due to all the errors, the answer will also contain some errors, right? So how will you write it? You will say that delta A upon A into 100, that is the net error in the answer, right? In the resultant, okay? So that will be n times whatever power is there, that becomes coefficient. Power becomes coefficient. So n times delta A upon A into 100 plus m times delta B upon B into 100, right? Plus k times delta C upon C into 100. All right. So they are giving you the value. This error delta A upon A into 100 is 1%. This is 2%. This is 3%. So just put the values, you'll get the answer, right? I hope the idea is very, very clear, Rahul. Okay. Okay. Right. All right. When such session will come, like the conceptual session, this is also going to come in, let's say, in few days, right? In less than a week. Okay. So now let's cover this particular thing, right? So just look at this question and try to solve in the chat box again. So you have a metal wire that has a mass 0.4 plus minus 0.002. So in the measurement of mass, you may have occurred this particular error, right? 0.4 plus minus that many grams. In the measurement of radius, you have also incurred some error, 0.3 plus minus 0.001 mm, and in the measurement of length also you have incurred some error, right? So in the measurement of all the quantities you are making some error, right? The maximum possible percentage error in the measurement of density will be, so what is the formula for density, my dear kids? Density is mass upon volume, right? And here we have this particular thing, volume, mass upon volume, right? And because we have a metal wire, so what will be the volume of a wire, you can say, right? We have a metal wire, so what will be the volume? We can say that it is pi r square, right? N into h, okay? So this is going to be the volume of this whole thing, right? So just put it over here and try to solve it. So you see that clearly it depends on these three things, right? It is depending on h is the length of this thing, h is the length of the wire, r is the radius of the wire, right? So you see that m upon pi r square h. So this is how you can just go ahead with it, right? And now you see that measurement of the density. So in the measurement of mass, you are making some error. In the measurement of mass, you are making an error, right? This, okay? In the measurement of radius, you are making an error. So radius is measured and this is the error that you are getting in the radius, right? In the measurement of length, h is the length of the wire, right? In the measurement of length also, you are making some error, right? So depending upon that, you just go ahead and try to solve it again, right? Okay. You can just go ahead and try to solve it. Okay. All right. So today we are going to solve 50 such random problems, like 50 such problems. They are not definitely random, right? We have picked them up based on which, like what kind of problems are asked recently, and it is highly likely that they will repeat them, right? Okay, they'll repeat them. Okay, so see that it is asked in 2023, right? So the questions on error analysis are very, very important, and how to solve the algebraic based error, right? All right. So you know the expression. So I have just explained you how to deal with it, right? You know the expression. So delta, if you're calling density as D, you can also call it rho. That doesn't matter, right? So that the percentage error in density is going to be 1 times, right? Percentage error in density, delta D upon D into 100, right? That is percentage error in density. That depends on delta M upon M into 100 plus delta pi is a constant, we cannot make an error in that, so 2 times delta r upon r into 100, right, plus h 1 times delta h upon h into 100, right? So just go ahead with it, right? And once you put the values of each thing, here they are not telling you the percentage error. In the previous question they were telling you the percentage error in the mass, in the first quantity it was 1%, but here they are not telling you the percentage error. Delta m is this 0.002 and m you have 0.4. Similarly delta r is this, right, and r is 0.3. So that just like that you can put the values, right? Just like that you can put the values. The errors are given individually. Yes, comic vibes. Good evening, beta. Right. So you see that this is how you can go ahead and try to solve it. Okay. All right. Again. So this one was solved first by Maxwell. Right. Nice. All right. So here you can see that as I have already explained you the concept. So what is really happening? The volume of the wire is pi r square into the length of the wire, which is, I have assumed it is h. Here they have taken L. That doesn't matter. So pi r square into L, that is the volume of the wire, right? Once you know the volume of the wire, the density will be mass upon volume, right? So density is mass upon volume, mass upon this thing, right? So you know the error in each one of those quantities, error in mass, error in radius, error in length. So clearly you can do that, right? Delta rho upon rho into 100 is delta m upon m into 100 plus 2 times delta r upon r into 100 plus 1 times delta l upon l into 100, right? And each value is given to you now. Delta m is given 0.002, right? Here you see that 0.4 plus minus 0.002. So this is the mass, that means this is the value that you have measured, and this is the possible error, delta m, right? This is m and this is delta m. Similarly, this is r, this is delta r, this is l, this is delta l, right? So just put the values over here and you will get the answer like this, which is 1.6%, right? Here you will get the answer 1.6%, okay? All right. Now, in this question, there is one key idea or one silly mistake that you can do. So let me explain that part as well. In this question, many kids were confused. They said, sir, one quantity is given in grams, okay. Now, one length is given. The radius is measured in millimeters, while the length is measured in centimeter, right? Radius is measured in millimeters and length is measured in centimeter. So, while using the formula of error calculation, do we have to convert the units? Answer is no. Why so? Because you see that here they are telling you this length is 0.3 and the error is also 0.001. If this is measured in mm, the error is also measured in mm, right? So when you are going to write, this is what? Radius. So when you are going to write delta r upon r, delta r is in mm and r is also in mm. So mm upon mm is unitless, right? So that will be cancelled. You don't have to convert it. Similarly, when you are going to write error of length, so you will write delta L upon L. Delta L is in centimeter, L is also in centimeter. You don't have to convert it, okay? Right? I believe the idea is very, very clear. You don't have to convert it, okay? So this was a very good question, okay? It was a small question, but again, it has multiple options where it can confuse you, and I believe the idea is very, very clear, okay? क्या लास्ट मंथ में एनसीईआरटी एक्सरसाइज सॉल्व करनी चाहिए? Definitely. Agar if you do not have really good preparation and you are considering a drop year, right, go ahead and start your preparation right away. This is what I've told you in the last session as well. Let's move ahead and talk about the next question. The area of rectangular field, previous question was very good, right? Just make a screenshot or highlight that question, right? The area of rectangular field in meter square of length is 55.3 meter and width is 25. After rounding off the value for correct significant digit is, so you are calculating the area and you have to explain the answer in the correct significant format, right? So take the correct, there are some rules for writing significant figures. So you have the chat option open for you. Just try to solve it. Calculate the area. You know the length, you know the width, right? Rectangle ka area kya hai? You know the area of rectangle, length into width, right? But the answer should be in correct significant figures. So just put it, okay? Right. You have to find the area. The length is given 55.3 meters. Width is given 25 meters, right? So for area, just multiply them and put the answer in the correct significant digit format, right? Okay. All right. So try to put it. So I'll explain as well. Surya is saying B. Okay. Right. Length is given, width is given. Try to explain it, right? What will be the correct answer in terms of correct significant digits, right? Very good. Isha is saying C. Swarna is saying D. Okay. If you are solving 50 questions which can be asked, like which are highly likely to be asked in the upcoming exam, right? Because that's the trend, right? We can only predict, we cannot guarantee. But the thing is, if you can solve these 50 questions, you will have a very clear idea about what kind of questions are asked from these chapters in the main exam, right? Okay, sorry. So I hope the idea is very, very clear. Right, let's see that how many of you have solved it correctly and who has solved it correctly. So here only one kid could solve it correctly, which is Swarna Ramesh, right? So Ramesh solved it correctly. So understand that how to go about this particular question, okay? My dear kids, let us say, what is the idea of writing the significant figures? Think about it. Let us say the result comes out to be 1382.5, okay? How many significant figures do we have over here? Answer it in the chat box. If we are writing like this, let's say that we get this much answer and we have to write the answer in until 2 significant figures, right? We have to put the answer in 2 significant figures, right? Right now, how many significant figures we have? We can say that 1, 2, 3, 4, 5. There is a decimal number, but all the numbers are, complete digits. They are integers. They are significant, right? So all of them are significant right now, but we have to round off, right, till 2 significant digits, right? So 2 significant digits, if you are taking 13, so this answer is unacceptable because the total final answer was 1300 and you are rounding off to 13. Let's say that you go to a market, to a shop, and you buy something. The remaining amount you want to get from the shopkeeper is 1300 something rupees, right? That is how much money you can get from the shopkeeper, right? But sir, he'll say that, sir, I have rounded off that money and I'm saying I'm going to give you 13 rupees only. He will say, Abe, give me my full money. Yes or no? Right. So in these situations, how can you round off this whole thing to 2 significant figures? So you can use the scientific notation. That means 13 point this into 10 to the power something, right? 10 to the power something, and that remaining part you can remove. I believe the idea is very, very clear, right? So let's have a look at that. We know the length is given 55.3 and width is given 25 meter, right? So area is going to be length into width, 55.3 into 25. Look at that. Length has 3 significant figures, 1, 2 and 3, right? All 3 of them are significant. Width has only 2 significant figures, right? So the answer should have only 2 significant figures, right? So we have to round off the answer till the minimum value. That is the idea of product. Yes or no? When we take a product of 2 numbers, the resultant of those 2 numbers must have the significant number of significant figures equivalent to the lowest digit, right? Yes or no? So here you have the 2 significant figures. The answer need to have 2 significant figures only, right? So when you multiply them, length into width, this is the answer you get, 1382.5. So you cannot only take 13, right? So you have to put in a scientific notation. So that when you do that, 1.3825 into 10 to the power 3 meter square, right? No problem with that. Now you can say that when you try to round off till two significant digits, you see that the number after this particular thing, right, the number after separation digit is more than 5. So previous number will increase by 1, right? So that will become for 1.4. So it will increase by 1. So it will become 1.4 into the power 3, right? So you can also write it because that is not there in the option. It is also complete and it is also correct, but that is not there in the options, right? 10 to the power 3 terms is not there in the option. So we can say that this point can be removed and it can also be written like this. So these are all the same things, right? Because this part does not decide the number of significant figures. So it can be 10 to the power 2 or 10 to the power 1. That doesn't change, right? So I believe the idea is very, very clear. 14 10 to the power 2 is the right answer. And option D here is the correct option, right? So three ideas are very, very important from this chapter. Error analysis, significant figures, and principle of homogeneity is very, very important. Let's move on and talk about this particular question. The quantities which have the same dimension than those of solid angle, right? Which of the quantities have the same dimension as that of solid angle? Answer it. Okay, it's a slightly decent question. It is asked in year 2024. So you see that from the dimensional analysis, previously they were asking about a particular physical quantity and they were asking what is the dimensional formula of this specific quantity. Now they don't ask the dimensional formula of a specific quantity, rather they ask questions like these, right? So which help you to think more. Okay, simple question is there, so just think about it and try to answer it. Okay, answer it in the chat box. Okay, answer it in the chat box. The quantities which have the same dimensions as those of solid angle. So solid angle ka dimension kya hai? What is the dimension of solid angle? Right? Think about it. Solid angle is caused by created by an area. So if we know that this is let's say a ball like this, right? This is the ball like this. So a small portion on the ball is going to subtend an angle at the center. That is a solid angle, right? A small area on the ball is going to subtend an angle at the center. This is a solid angle, and solid angle is this area upon square of distance, right? The area is length square, dimensional formula, and a square of distance, that is also length square. So this is dimensionless. Solid angle is also a dimensionless number, right? So clearly we have to select a quantity that is also dimensionless, right? Very good, very good. So Malika Arjun is saying A, Yuvraj is saying A, Hruday is saying A, Surya is saying A, Kulberg is saying A. Very nice. Let's say that who among you is actually correct. Okay. So let's say that who is actually correct. So yeah. So here Yuvraj gave the answer fastest, then you have Hruday, you have Surya, and then you have Kulberg, right? So of course the option number A is the correct option, because we have to look for a quantity that has same dimensional formula as solid angle. Solid angle is dimensionless. Solid angle is this area upon square of distance, right? Area has a dimension of square of length, square of length, also square of length, right? So this is L square upon L square. So this has no dimension, M0, L0, T0. So we have to look for ratio, right? Whenever we are looking for a dimensionless quantity, we are looking for the ratio of two same things. If you go for length upon length, area upon area, mass upon mass, things upon things, hathi upon hathi, right? If you look for this ratio of two similar things, you get a dimensionless quantity. Strain is change in length upon original length, length upon length, right? Ratio of two similar quantities is dimensionless. Angle is, arc upon radius, length of arc upon radius, length upon length, again dimensionless. So of course you don't have to look any further. Option A is the correct option. I believe I'm making some sense to you, right? कह रहा है बेटा ईशा पांडे 1382.5 1.38 10 to the power 5 होना चाहिए सर. बिल्कुल बेटा ये होना चाहिए था, बट दैट इज नॉट गिवन इन द ऑप्शंस, राइट? वी हैव 4 ऑप्शंस. आप क्या के पेपर से लड़ोगे कि सर मुझे ये क्वेश्चन क्यों दिया नीट वालों, राइट? यू कैन नॉट फाइट अगेंस्ट देम, राइट? यू हैव टू चूज आउट ऑफ दीज 4 ऑप्शंस, right? And you can round off, जैसे कि मैंने आपको बताया, you were getting that kind of option, my dear kid. Okay, 1.385 into 10 to the power 3. You need only two significant figures, right? So you have to round off this portion. So the portion which is rounded off, right, this separation digit is more than 5. So previous number has to be increased by 1, Isha. Got it? Okay. Now let's move on and talk about the next question. So I believe you got some idea about what kind of questions you can expect from units and measurement, right? Without wasting any time, let's move into the part of kinematics. So if you guys are ready, let's start with kinematics. Arc has a dimension of length, and stress has a dimension of pressure. My dear kids, we are talking about strain and angle, strain and angle, right? Okay, don't get confused. Strain is change in length upon original length. What is stress? Stress is force per unit area, the reaction force per unit area. So stress has same dimension as that of pressure. Okay, but angle, as you know, that angle is dimensionless. Okay, right. So let's move on and talk about the kinematics. Okay. All right, all right. Surya, clear हो गया बेटा? Okay. Kinematics के बारे में पढ़ेंगे. So kinematics में the first question is, a vehicle travels half the distance with the speed v. Before we start, what kind of questions are asked from kinematics? Generally they ask questions from calculation of average speed, average velocity, and average acceleration. Average acceleration is not asked many times, but they ask the questions of average speed and average velocity. So these kind of questions are asked multiple times. The second kind of question that are asked are mostly graph based. Okay, and third kind of question which is asked from kinematics is equation of motion, right? Equation of motion. All right, and at last, if we talk about kinematics, we have motion in a plane as well. So in motion in a plane, within the projectile motion, there are certain kind of problems that they ask, right? So in the projectile motion, the main kind of problems that are asked is the energy. Just the three basic formulas: height, time of flight, and range of projectile motion. That is something you already know, right? But the energy consideration of the projectile motion, that is something you have to do, right? So these are the four things which are asked many times, and kids are generally committing mistake in this particular portion, where they have to understand and calculate the energy associated with the projectile motion, right? Okay, so let's start right away with the first question, my dear kids. A vehicle travels half the distance with the speed v and the remaining distance with the speed 2v. The average speed is, so what will be the average speed, right? Look at the question and try to solve it. Okay, look at the question and try to solve it. Slightly good question. You have, I gave you 30 seconds more to solve this one, right? A vehicle is traveling half the distance with the speed v. So half the distance with the speed v, and remaining distance with the speed 2v. So remaining half with the, speed double of the previous one, 2v, right? What will be the average speed? Try to solve it. The concept behind this question is very, very same, right? I've already explained you the same concept multiple times. Average speed is total distance upon total time. That's it. The concept is absolutely same, right? Very good. Isha Pandey is giving the answer. Surya is giving the answer. Beta, Surya, give us which of these is option is correct, right? So that's why this software will pick your option, right, and show me over here, right? Very nice. Mallikarjun is giving the answer. Very good. Surya, very nice. Okay. Right. So just try to solve it. The idea is very, very same. Concept of this question is how to find the average speed. So average speed is total distance upon total time. Total distance upon total time. So this is the idea. Total distance will be distance in the first half plus distance in the second half, right? So how will you find the distance in the first half? This is the first half, this is the second half. You will call it the distance traveled over here is going to be how much? Let's call it d by 2 and d by 2. Okay. All right. So the first half is traveled by v, the second half is traveled by 2v. So the time taken in the first half will be distance upon velocity. This is the time taken in the first half, and this is the time taken in the second half, right? So d by 2 plus d by 2 is the total distance, and d by 2 upon v and d by 2 upon 2v, that is the total time, right? Just add them up and take the ratio, you will have the final answer. Okay. Very good, Coolberg. Very good, Yuvraj. Let's see that how many of you are giving correct option. How many are giving correct answer, right? So let's see. Everybody gave the correct answer, and the fastest answer was given by Isha, right? Then Surya, then we have Mallikarjun, then Coolberg, and then Yuvraj. Okay. So let's see that. This is the way you solve it. As I said already, that total distance upon total time you have to do. Total distance upon total time. If you further solve it, it comes out like this, right? So the value is same, right? D by 2 plus D by 2. You can do it like this. D by 2 plus D by 2. This is the total distance. And total time. Time in the first half is distance upon velocity. So distance upon speed. D by 2 upon V. This is the time in the first half. D by 2 upon V. And this is the time in the second half. D by 2 upon 2V. That's it. So just add that up and solve it, and you will have the final answer. Let's move on and talk about the next part. Now, this is a graph based question, right? Look at this and try to solve it. Very simple question asked just few years back, 2022, it was asked, right? And simple question. Whenever you see a question on graphs, right, that is where you are going to save some time. Okay. You either know it or you don't know it. There is no middle ground. Okay. Look at it. The displacement time graph is shown of two moving particles. They are making an angle 30 degree and 45 degree with the horizontal like this. Okay. The ratio of their respective velocity is, the first displacement time graph is making 30 degree, the second is making 45 degree. What will be the ratio of their respective velocity? What will be the ratio of their respective velocity? So think about it. Which part of the displacement time graph tells you the velocity? Can I say that? Answer me. Slope, right? Slope tells you that, or area under the curve, right? Which of these two things in the displacement time curve explains you about the velocity? Think about it. One or two. Is it the slope of distance time graph that tells you the velocity, or is it the area under the curve? Is it the slope or is it the area under the curve? Very good, Isha, right? M is tan theta, yeah. So definitely it is the slope. Very nice, right? So now you just have your pole and try to solve it. It's a simple question, so you can solve it very clearly and very fast. Okay. Slope, nice, very nice. 60 seconds you have and try to solve it. Right. Just try to solve this question in 60 seconds. Right. So we will be picking few more questions on the graph as well. Very good, Mallikarjun. Very good, beta. All right. So what is the ratio of the respective velocity? So as you know, that velocity is nothing but the slope of distance time graph, which is tan theta. So tan theta for the first one and tan theta for the second one. You see that? For the first one, tan 30 upon tan 45. That is your answer. Tan 30 upon tan 45. That is your answer, right? Tan 30 is 1 upon root 3. Tan 45 is 1. So 1 upon root 3 into 1 is 1 upon root 3. So option D is correct option. By without even solving it, you can tell that, right? So the time is about to go up. So yeah. So the fastest answer here was given by Coolberg, then Yuvraj, then Isha Pandey, then Surya, and then Mallikarjun. So here we have it. Option D is the correct option, right? Let's look at this question and try to solve it. The velocity time plot for a motion of a body is shown like this, right? So velocity time graph is like shown like this. Velocity time graph is shown like this, right? The acceleration time graph according to this is, which of these is correct? Okay. Velocity time graph, you know, right? You have to plot the acceleration time graph. Now you tell me first of all, which part of velocity time graph tells you the acceleration? Is it the slope of velocity time graph, or is it the area under the curve of the velocity time graph, right? What tells you about the acceleration in the velocity time graph? Is it the slope or is it the area under the curve? One or two? Clearly, slope is dv by dt. For the velocity time graph, dv by dt is acceleration, right? So clearly it is the slope of velocity time graph that tells you the acceleration. So look at that. Whenever you have constant slope, you have constant acceleration. Whenever you have zero slope, that means zero acceleration. Whenever you have again declining slope like this, you have negative acceleration or retardation. So have a look at that and try to answer it, right? I'm starting the poll over here, right? And you don't need much time to solve this question. So 60 seconds are enough. Very good, Isha beta. Very good, Malkarjun beta. Right. So try to solve it. You know the velocity time graph looks like this. So what will be the shape of acceleration time graph? So here you see, here in the first part, what is happening? Slope is constant. So there is a constant acceleration in the first part. Then from here to here, there is no slope, zero slope. So there is no acceleration. And here we have negative slope, right? Negative slope. Tan theta is negative over here. So clearly the slope is negative. That means acceleration is negative, right? So here you see that all the acceleration is positive above the axis. And here you see that either it is C or D, right? Here we have negative acceleration. Here we have negative acceleration, right? So which of these is correct? Very good, very good. Yuvraj is giving the correct answer. Mallikarjun is giving the correct answer. Surya is giving the correct answer. Isha, Kulberg, everybody is giving the correct answer. So let's have a look at who is giving the correct answer and who has given the answer fastest. So you see, Surya has given the fastest answer. Then we have Yuvraj, Mallikarjun, Isha, and Kulberg, right? So let's have a look at the further part. So here you see that for this part, constant acceleration. You see that constant acceleration, right? Okay. And for this part, there is no acceleration. So you see that there is no acceleration. And for this part, there is negative acceleration, but constant. So negative acceleration, but constant. You see that below the axis you have to draw. So option C is the correct option, right? So you see that looking at the graphical questions and solving them is the fastest way to get 4 marks, right? A horizontal bridge is built across a river. A student is standing on the bridge. He throws a small ball vertically upward with a velocity 4 meter per second. So horizontal bridge is built across a river. A student is standing on the bridge. He throws a small ball vertically upward with a velocity 4 meter per second. The ball strikes the water surface after 4 seconds. The height of the bridge above the surface water is. Very simple question, right? Simple question, but slightly good question, right? So it is asked in 2023, right? A simple question of motion under gravity. Try to solve it and your time can start right now. Okay. All right. So try to solve this question over here. Right. Now, when we are saying that he is throwing a small body, right? He is throwing a small ball. So the question is simply saying that the initial velocity is not zero, right? The body starts the motion at 4 meter per second. Initial velocity is given 4 meter per second, right? Then the ball will reach at the highest point. So at that point, the velocity will become zero. So what will be the time that it will take to reach to the topmost point, right? Think about it. Try to solve it. Very nice. Try to solve it. Half of the time is already up. Surya is solving it correctly. Perfect, Surya. So you have done that part, right? Like you have calculated the distance in the first part and then you have subtracted in the final value. Yes, that is also correct. All right, so let's see that. How many of you have given the correct option? Yes, so this one was answered by Koolberg and Surya, right? So those kids who are not able to solve it, we can definitely go ahead and look at this particular question. Generally, they ask the question on motion under gravity. Like they ask a very simple question on motion under gravity. This is a slightly good one, which is why I picked this question, right? Now, what is really happening? Think about it. There is a horizontal bridge that is built across a river. So this is one end of the river, this is another end of the river, and this is how the horizontal bridge is. Okay, right? This is the horizontal bridge is. A student is standing on the bridge. He throws a small ball vertically upward with a velocity of 4 meter per second. So he throws a ball vertically upward, and this ball will come down and it will hit the ground. Okay, like this. All right. So with he throws a ball vertically up with 4 meter per second. The ball strikes the water surface after 4 seconds. The ball strikes the water surface after 4 seconds. So he launched the ball, and after 4 seconds it is going to hit the ground. Okay. So the height of the bridge above the water surface is. So we have to talk about this particular part, right? We have to talk about this particular height of the bridge above the water surface level, right? So we know the 4-second part. 4 seconds is the entire journey, right? 4 seconds is something that is taken by the entire journey, right? Yes or no? 4 seconds is taken by the entire journey. So if we remove the time taken it by the time it takes, to cover the first half, this particular part, right? We remove that particular time from the 4 seconds. So that means the remaining time is the time it took to travel from the bridge to this particular water level, right? So that is the time that we need, right? For example, you see that initial velocity of the body was 4 meter per second. He is throwing the ball with 4 meter per second. At the topmost point, the velocity will become 0, right? And the value of g is 10 meter per second square without any problem, right? You apply the first equation of motion so that you can get how much time it takes to reach the topmost point. So by solving it, you get 0.4 seconds, right? 0.4 seconds. So 0.4 second is something that is not invested to travel from bridge to the ground, okay? So from total time of 4 seconds, if you remove the 0.4 seconds, so you have the time that it takes to travel from this place to that place, right? So yeah, now you can say talk about that. The S is equals to ut plus half at square. So just talk about this particular part, right? If the body is dropped from this place, right? So initial velocity is 0, time is 3.6 seconds, right? Plus half at square, a is 10, and t is the time it takes to travel from here to here, which is 3.6, right? So put t is 3.6, total time was 4 seconds, right? And 0.4 seconds was to travel from here to here. So if you remove it, the remaining time is 3.6 seconds. The remaining time is 3.6 seconds. From here to here, the body will take only 3.6 seconds, right? So the problem is now reduced that you have 3.6 seconds to travel from here to here. What is the distance, right? A body is dropped. It will take 3.6 seconds to travel from here to here. What is the distance? So S is ut plus half at square. Time you can put 3.6 seconds. Initial velocity is 0, right? And when you solve it, S will come out to be 64 meters, which is option A. I believe the idea is very, very clear, right? Surya has also solved it by taking the displacement part. That is also correct. Now look at this thing. The ratio of distance traveled by a freely falling body in the first, second, third and fourth second is. So this is something I have explained you while explaining the Galileo's laws of odd number, right? So look at this particular part and try to answer it. It is asked in 2022 this kind of question if you don't know the law already. See, think about it. They are talking about the distance the body will fall in the first, second, third and fourth second. This is a question which is simply based on concept, right? Galileo's law of odd number, right? A body that is falling, right, it will travel certain distances in every next second, right? The ratio of those distances are in odd numbers, right? You can calculate that as well, right? A body is falling, so it is accelerating. Initial velocity is 0. So from 0 it will accelerate. It will have some velocity after 1 second and it will travel some distance in the first second, right? Now it has some velocity and again in another second it will move, but it will move much further. So this is S2, and clearly in the next second, third second, it will travel much farther. In the fourth second, it will travel much farther. So if you take the ratio of S1, S2, S3, S4, that ratio of distances traveled in consecutive seconds can turn out to be an odd ratio, right? So you can calculate it. right? You can just go ahead and solve it and take the ratio. It comes out to be in a ratio of 357 like this, right? So yeah, that's the idea. That's the idea, 1357. So I believe these kind of questions where the calculation, now you're not going to do all that in the exam. So those kids who know about the Galileo law, they can make a right tick. Otherwise, this question is a type of question that you have to leave, right? Think about it. They are asking about 4 ratios, right? So 4 ratios, NEET is not going to ask you a question which is that kind of lengthy. If they ask you a lengthy question genuinely, then you have to consider it for the last. But this is a conceptual question. I believe the idea is very, very clear, right? Many kids already know that. Yes. All right. So let's move on and talk about the next one. Look at this question. A ball is projected from a point A with the velocity 20 meter per second. 20 meter per second. Okay. At an angle 60 degree to the horizontal, at the highest point B of the path, the velocity V in meter per second of the ball will be. At highest point, what will be the velocity? If you throw a ball vertically up, at highest point, the velocity is going to be 0, right? But in this situation, at highest point, the velocity will not be 0, right? So answer it in the chat box. Again, a very simple concept is applied over here, right? Answer it in the chat box and tell that which of these option is going to be correct. Answer it in the chat box, like which of these option is going to be correct. A body is thrown at an angle, right? What will be the velocity at the topmost point? Very nice. A body is projected like this. What will be the velocity at the topmost point? Very good, Yuvraj. Very good, Kulberg. Okay. वेरी गुड स्वर्ण सर फिजिक्स में लास्ट कितने ईयर्स के बेटा, एक सेकेंड, ये जो है ना लास्ट 37 ईयर्स नीट PYQs एंड जेई मेंस 26 25 लास्ट 3 ईयर्स के जेई मेंस क्वेश्चंस, NCERT एग्जाम्पलर एंड इंटेक्स क्वेश्चंस, revision enough to get 160 plus? Definitely yes, right? That is a lot of practice and that is going to definitely take you somewhere. Very nice, Isha. Okay. All right, all right, all right. So I believe the idea is very, very clear and the time is over now, right? So how can you go ahead with it? So the idea is, let's see. So yeah, everybody gave the right answer and yeah, so the fastest answer was given by Yuvraj and then you have the Kulberg. So basically the idea is very, very clear that there are 2 components of the velocity. There is one horizontal component and one vertical component. So there is 20 cos 60 and 20 sin 60. The vertical component is affected because of the acceleration, but the horizontal component remains as it is. So at the topmost point, there is no 0 velocity, only the vertical component gets 0. Horizontal component remains same as it is throughout the journey, which is 20 cos 60. 20 cos 60. Okay. So cos 60 is what? 1 upon 2. So it is 20 into 1 upon 2 is 10. So option D is correct. All right. So let's move on and talk about the next part. A bullet is fired from gun at a speed of 280 meter per second in the direction 30 degree above the horizontal. The maximum height attained by the bullet is. Again, it is asked in year 2023. So as I was telling you, from the projectile motion, they ask you 3 kind of questions. So in the previous question, they could have also asked you what will be the energy at the topmost point. What will be the kinetic energy at the topmost point, right? So the kinetic energy at the topmost point will be half mv square, and velocity, there is only one velocity, which is the horizontal velocity, 20 cos 60, 10 meter per second. So in half mv square, put the mass and velocity 10, right? So if they are asking what is the energy at the topmost point, you can definitely calculate it, right? Or otherwise, they are asking questions like this from the projectile motion, which are directly based on the formula, right? Look at the question and try to solve it. Look at the question and try to solve it. So from the projectile motion, generally they ask you these 2 types of questions, right? They ask you about simple energy considerations and simple formula based questions, right? So you don't have to invest so much time on the projectile motion, right now at this moment, if you have not done it already, okay? Right, you have to just talk about the maximum height attained by the bullet. What will be the maximum height attained by the bullet? So you know the formula, it is most welcome, beta. It is u squared sin square theta upon 2g. So what is the maximum height at an angle theta? U square sin square theta upon 2g. Right, my dear kids, many kids do a mistake when they write the formula. So if you are making mistakes while writing the formula, it is a best practice to revise it very regularly, right? So u square sine square theta upon 2g, just put the values and you'll get the answer. Okay. All right. Very good, Surya. Very good. So the time is up. I believe you could not solve it. The time was not that much to calculate. But anyway, just put the values and you will have the answer, right? So I guess the option A should be the option. So no problem. The question was simple. I believe you didn't get the time to solve it. So u square is simply 280 square. You don't have to convert it. Sine square theta is sine square 30. And 2g is 9.8. So you just put the values and you will get the answer, right? Okay. So these kind of questions are expected. Now the next thing is laws of motion, right? From the laws of motion, many kids invest so much time in solving the wedge-based problem. Many kids invest so much time in solving block and block problem. Many kids invest so much time in solving pulley-based problem, right? But my dear kids, these are not the only kind of problems which are asked in the previous year NEET papers, right? They are asked but not at a very difficult level, right? Very basic level of wedge based problem, particle problem, and the pulley based problems are asked in the previous year NEET papers. You don't have to waste time on the difficult type of problems in this category. And the second is, mostly they ask you the questions on second law, right? Let's have a look at some questions from this part of Newton's laws of motions. Let's have a look at that. Okay, so just start right away, my dear kids. Okay. So height was 1000 meters. So in the previous one it was 1000 meters. Very good, Surya. So let's start with the first question of Newton's laws of motion. A ball of mass 0.5 kg is dropped from a height of 40 meters. It is dropped from a height of 40 meters, means the initial velocity is 0. The ball hits the ground and rises to a height of 10 meters. So it is dropped from 40 meter, but after hitting the ground, it doesn't rise back to the 40 meter. It loses some of the energy and only rises back to 10 meters. Dropped from 40 and rises back to 10 only. Okay. The impulse imparted to the ball during its collision with the ground is, what is the impulse which is imparted to the ground? This is the question of impulse momentum equation, right? That is the hint I'm giving you, right? This is the question of impulse momentum equation, right? Again, which is the application of Newton's second law, right? If you know the second law, you can definitely talk about impulse momentum equation and solve this question. As I said, Newton's second law is very, very important. So impulse momentum equation also falls into the same category of second law. So just go ahead and try to solve it. Very, very simple numerical. But again, if you don't know the basics, then again it is difficult. So I will explain you the concept, and meanwhile, so over here I am explaining you the concept. So those kids who don't know it will get it from here, and those who know it can solve it. So this is the concept, my dear kids. You know what is impulse? So impulse is force into delta t, right? F into delta t, right? It tells you that for a fraction of a second, the force is imparted to a body. So what will be the effect of that force which is applied for a fraction of a second? You hit the ball with a bat, right? Something happens with the ball. It changes the direction. It moves with a certain velocity. How much impulse is imparted in that situation? So how will you calculate it? You know that rate of change of momentum. What is that? This is the force acting on the body. This is the Newton's second law. Force acting on the body is rate of change of momentum, dp by dt, right? So here dp is equals to f delta t. dt you can take it on the other side. dt will go over here. So f dt, what is this? This is impulse. So impulse. So you see that impulse that is imparted to the body is equals to the change of momentum, right? Impulse imparted to the body is equals to change of momentum. So what is really happening? The ball is striking back to the ground, right? Think about it. The ball is falling from the height of 40 meters, hitting the ground and going back to the height of 10 meters only. Think about it. What will be the velocity at which it will jump, right? It is going to the height of 10 meters. So the energy it has is mgh. H is 10 meters. Right, and it starts with a velocity v, let us say. It bounced back with the velocity v, let us say. So it is half mv square. So m and m is cancelled. From here you can calculate the velocity. At what velocity it is jumping back? Right, you already know like what was the velocity before it strikes the ground, right? It is falling from the height of 40 meters, right? It has a certain mass m, let us say. So what will be velocity right before it hits the ground? Under root 2gh. This is the velocity right before it hits the ground, right? So you know the velocity before it hits the ground, v naught. You know the velocity after hitting the ground, v, right? Let us say that before hitting the ground it was moving with 40 meter per second, and after it is moving with 10 meter per second. So clearly there is a change in momentum, m1 into v1 and m2 into v2. Subtract it, whatever change of momentum you are getting, that is the imparted impulse. I believe the idea is very, very clear, right? So impulse imparted to the body is equals to the change of momentum. Simple question, but very interesting and very interesting numerical. So see that in 2025 they are asking you this question, and this particular question is utilizing three concepts. First, it wants you to calculate the velocities, right? Velocities. Then once you have calculated the velocities, then you apply the impulse momentum equation, right? So again, it doesn't require so much of difficult thinking. Okay, so let us see that how many of you were actually correct. Oh, the fastest answer here was given by Surya, right? And how to solve it, as I said, as I've already explained you the main idea behind it, that before striking you are dropping it from a height of 40 meter. So just before the ball strikes the ground over here, just before hitting the ground, what will be the velocity? Under root 2gh. So under root 2g into 40, this is the velocity before striking the ground. Okay, after striking, this is 28 meter per second. So with 28 meter per second it is going to strike the ground, and it is going to jump back, will go to the height of 10 meters. So with that data you can calculate what will be the velocity at which it will leave the ground. So it is 14 meter per second. So it is striking from 28, and after it is moving with 14 meter per second. So m1 v1 and m2 v2 you can calculate and subtract it. So what will be the momentum? M v2 minus v1, right? So just put the values and you will have the change in momentum. Whatever change of momentum you have, that is equals to the impulse imparted. Change of momentum is the impulse imparted, right? So just put the values. Mind you, if you are taking this velocity as positive, the other velocity you have to take with a negative sign. If you are taking this as positive, this velocity you have to take with a negative sign, which is what we have done over here. Minus sign is coming with 28 meter per second. We are calling upward velocity 14 as positive, so 28 will be negative, right? So minus sign is used over here, right? And when you calculate it, 21 units का momentum change आ रहा है. All right, सही है? Let's move on and talk about the next part. We have 1 kilogram object that strikes a wall with a velocity 1 meter per second at an angle 60 degree with the wall and reflects at the same angle. We have a 1 kilogram object that strikes a wall with a velocity 1 meter per second at an angle of 60 degree. So this is the wall, right? And 1 kilogram object, it strikes at an angle of 60 degree, right? If it remains in contact with the wall for 0.1 seconds, so 0.1 second, for that little time it remain in contact with the wall, right? It will lose some of its momentum, definitely. Then the force it exerts on the wall is going to be. So how much force it will exert in that much time on the wall? Try to answer it, right? Again, the similar concept, okay? And I will tell you that the impulse momentum equation is going to be very, very important in this year, right? Okay, so I should give you some time to solve as well, right? So try to solve this particular question in the chat box. Okay, try to solve this particular question in the chat box. All right, how will you calculate it? You know that force acting on the body is delta p, dp by dt, right? So change of momentum, how much change of momentum will happen, right? How much change of momentum will happen? Mv sine theta is the one component of this particular velocity. You see that this body is going to hit like this, right? And after striking, it will go like this, right? So clearly one component of momentum you can cancel like this, which is cos component, you can cancel out, and the sine components will add up. So it will become sine theta and sine theta, right? So sine components will be adding up. So you can write down p sine theta, p is momentum. So mv sine theta plus mv sine theta is 2mv sine theta, right? Upon time is delta t, right? This is the force that it will be imparting on the wall, okay? So simply just put the values. Mass is given in the question, which is 1 kilogram. Velocity is given in the question, which is 1 meter per second. And sine theta is given is sine 60. Delta t is given is 0.1 second. Just put all the values. You can calculate the value of force in this question, right? Okay. You can calculate the value of force in this question. You see that if you can solve these questions, which are asked in recent years, right? In this particular video, I will be solving 50 questions, but hardly any question will be more than 5-year-old, right? I have tried to pick a question of each type, and that is not going to be very, very old question unless I really want to teach you something about it, okay? Okay, so let's have a look at that, if you were able to solve it completely or not. So Mallikarjun was able to solve this particular question, right? So I believe the idea is very, very clear to you how the thing is happening, right? This is the wall, okay? This is the wall. Think about it. If I throw a ball like this, then the ball is just touching the wall and just moving, right? Think about it. Will it impart any force on the wall? If the ball is just moving like this, right? Like if I take the ball and the ball is moving like this, right? Is it going to impart any force on the wall? No, unless I throw it at an angle or like this, right? So which component will decide? Think about it. If the ball is moving like this, right? This component of momentum is not imparting any force to the wall, right? The component of momentum which is parallel to the wall is not imparting any force, and the component which is perpendicular, that is something which is responsible for force. If I throw it like this, that is something which will decide how much force will be acting on it. Yes or no? So if you are throwing it at an angle, if you are throwing the ball at an angle, right, the momentum of the ball is p, right? So there are two components of the momentum. One component is like this along it, and one component is perpendicular to it, right? So think about it. Which component will be deciding, or let's say this angle is theta, right? So which component is responsible for applying the force on the wall? We can say this component is not responsible for applying the force on the wall, which is, let's say, P is the momentum. So P cos theta is not the responsible component. It is the P sine theta. Yes or no? And after jumping, the ball will move like this. After striking, the ball will move like this. Again, it will have two components of momentum. One is along the wall, and another is this way, right? So this way and that way along the wall. So you see that again P sine theta, and over here in the minus P sine theta. So the change in momentum will be P sine theta minus P sine theta. This is the change in momentum, which is 2P sine theta, right? What is P? Momentum M into V, right? So the change of momentum when the ball strikes at an angle theta is 2mv sine theta, right? And you know that the force applied is rate of change of momentum, delta p upon delta t. Okay, force applied in any interaction is rate of change of momentum. Change of momentum is 2mv sine theta, 2mv sine theta, and that is delta t, right? So just divide it and you'll get the ratio, which is the force applied on the body, right? So put the value of mass, velocity, angle is theta, and time is 0.1 seconds, right? I hope the idea is very, very clear. Concept is clear or not? Okay. Shall we move ahead? All right. Now again, we have a graph-based question. Look at this question. The force F is acting on a particle in this situation. The force is variable. The force is variable force, right? It is changing with time. The change in momentum of the particle over the time interval from 0 to 8 seconds is. So change in momentum, how much change of momentum will happen in this situation? Force and time. Think about it. They are asking about change in momentum. They are asking about change in momentum, right? They are asking about change in momentum, right? They are giving you the data of force and time. So how can force and time relate to the change of momentum? We can say impulse momentum equation we are talking about. Change in momentum equals to F delta T. F delta T is essentially change in momentum is F delta T. This is the impulse momentum equation. F delta T is simply the area under the force and time curve. Yes or no? F delta T, you know that if there is force and this is the time, this is the area under the force time curve. This is F delta T. Force and time, multiply that. On this axis you have force, on this axis you have time. So multiplying them, it will give you the area under the curve, right? So area under the force time curve is basically giving you the change of momentum. Yes or no? Right? Yeah. So this is the concept, right? This is the concept, right? So as I said, the questions based on impulse momentum equation are very important, right? So just you need to know how to apply it, how to go about the graphical aspects of it. Very, very important. Okay. So think about it. Now I have already given you the concept, and based on that, you can solve it, right? All you have to use your common sense, right? And think about the force here is positive, the force here is negative. Positive force means this way, the negative force means the other way. Think about it. The friction force acts opposite to velocity, right? So that increases the momentum or decreases the momentum. Here I'm applying the force and I want to make the body move faster. The friction is acting the other way, the negative force. That is slowing it down, no? That is reducing the momentum, right? So think about it, which has to be positive area, which has to be the negative area, and just add it up. Area under the curve is telling you the change of momentum. Now tell the final answer. Concept is clear? Concept clear हो रहा है? All right. So option C, Surya is saying option C. Mallikarjun is saying option C. चलो देखते हैं. बहुत बढ़िया बेटा. Right. Concept must be very, very clear. Right. So let's have a look at that. अभी टाइम बचा है करीब 20 सेकेंड और दिमाग लगाइए, कैलकुलेट करिए ए बी और डी. किसी का आ रहा है क्या? Why the remaining students are not responding to the questions? I don't know. All right. So whatever, like if you want to understand, you will try to solve it. These classes are free, so the free is not respected well, I guess. But anyways, just keep solving it. Every question is going to teach you something, right? Something you will learn after every question, right? Okay, and I'm trying my best to tell you about the idea that you should be using in the main exams, right? Okay. All right. So now the time is up, and here, yeah. So Surya and Mallikarjun both gave the correct answer. Surya gave the answer first, and here you have the option which is the correct one. So here this area is positive, 1/2 base into height, and this length into width, and subtract it from this area. Subtract this area from the final answer, and you will have it, right? So you see that 1/2 base into height is this area, 1/2 base into height, minus 3 into 2, which is this, okay, plus this area. So the total area you have 12 Newton second, right? The next question is this: there are two inclined surfaces of equal length L and the same angle of inclination 45. So this question I am placing over here for a specific reason. Now you see that this question was asked in 2025, right? But if the kid had a really good preparation, he would leave this question for the last, right? Look at the question and you'll understand why am I telling you that, right? Question has nothing very, very difficult, but just have a look at that. You'll understand why I'm telling you to keep these questions at last, for last. You see that there are two inclined surfaces of equal length, okay, and they have the same angle of inclination 45 degrees. So first surface is also 45 degree of same length, and second surface is also of 45 degree of same length, okay. And one of them is rough, the other is perfectly smooth. So this is rough and this is perfectly smooth, okay. A given body takes two times as much time to slide down on a rough surface than on a smooth surface. There is a body, right? that when it slides for the same length, because the length of these things are same, right? Okay, so if this body is sliding on a smooth surface, it takes the time t, right? And when the same body is sliding on a rough surface, it takes the time 2t. Why? Because the friction forces are going to slow it down. Okay, right. The coefficient of kinetic friction is mu k between the object and the rough surface. So between them, the coefficient of static friction is mu k, right? What would be the value of coefficient of static friction out of these four options, right? What will be the option? What will be the distance? What will be the value of coefficient of static friction out of these four options, right? Now, the conceptually, this problem has nothing like more, right? You can solve it very, very easily, right? You have to solve basic equations, right? And go ahead with it, right? Because you see that we know the displacement is same. S on the rough surface, displacement of the rough surface is same as displacement on the smooth surface. That is same, right? So S is half at square ut plus half at square. You can apply. Initial velocity is 0. So S is half at square, and here S is half at square, right? So clearly, here the time is time taken on the rough surface tr, and here the time is time taken on a smooth surface ts. You will simply get a relation between tr and ts from here, right? You will simply get an you will simply get a relation between the acceleration of these two surfaces. The s and s is same, which is the length of this particular thing, right? So you will get a relation between the acceleration of these two things. By knowing that, you can further solve it out by making the simple equation. So here, when the body is sliding down on a rough surface, this is the rough surface, the body is sliding down on a rough surface, the friction force is acting backwards, which is what? Mu k into n, right? Friction force is acting in the backward manner, right? So because of which the body is going to slow down, right? So if you just solve it out, how will you say? The question is giving you the time taken on the rough surface is 2 times the time taken on a smooth surface. They are giving you already that part. Now, because you know, let's say that body is simply sliding down on this surface with the initial velocity 0. What is the total distance it is going to travel? It is the length of the surface, which is s, let us say. So s is half a t square. Acceleration on a smooth surface is a smooth. Time is also t smooth square, right? Theta is 45 degrees, right? Okay, so what will be the acceleration over here on the smooth surface? It is not g, it is g sine theta, right? The acceleration is going to be g sine theta. So put acceleration is g sine theta over here, and here when you put the values of this thing, s will come out to be this, right? And the time taken on the smooth surface will come out to be this, right? Where what is s? S is the length of the surface. Length of the surface. Clearly you can go ahead and solve the same thing, right? In the case of rough surface, the acceleration will be g sine theta minus the acceleration caused by the what you can say, acceleration caused by the friction force, right, in the opposite direction, which is g sine theta minus mu k into g cos theta. How is that? So this is the rough surface, right? This is the body, right? In this direction, let's say the normal reaction is n, the weight is mg. So clearly it is mg cos theta, where this angle is theta, right? This is also theta. So n is what? Mg cos theta. N is what? Mg cos theta. What will be the kinetic friction? We can say kinetic friction will be mu k into n, right? Mu k into n, or you can write it out like mu k in place of n is equals to mg cos theta, mg cos theta. So what is the acceleration caused by the kinetic friction? This is the kinetic friction force Fk, right? How much acceleration will be caused by the kinetic friction? So acceleration caused by the kinetic friction in the opposite direction is force upon mass. So just divided by mass, it is cancelled out. It is mu k into g cos of theta, right? So see that g sine theta is due to the weight, and mu k into g cos theta is due to the kinetic friction. So this is the net acceleration on the rough surface, right? Net acceleration on the rough surface is this. So in the same formula, when you put the net acceleration, right, in the same formula, when you put acceleration on the rough surface and time on the rough surface, so you will get the time on the rough surface is like this. Time on the rough surface is like this, right? So you will get a weirdly long expression for this thing, right? Again, it is taking so much time, and you are solving it in the NEET exam. You are supposed to solve this question in 1 or 2 minutes. Think about it, right? So you have calculated time on the rough surface again. You know the time on the smooth surface. You know the time on the rough surface. Now in the question they are giving you the time on the smooth surface is half of time on the rough surface. So you just put the values, right? Time of the rough surface is 2 times time of smooth surface. Just put all the values and you can cancel out s and s from both sides and solve it further. You can get the value of mu equa. So you see that no part of the calculation was tough, right? All you have to consider the net acceleration, right? None of these part was tough, but the idea that it takes is time. Solving this question will take a lot of time. So if you get these questions like this in the NEET exam, you have to keep these questions for the last, right? So yeah, let's move on and talk about the next question, right? This is asked in year 2024, right? So just try to solve it. This is the question. A horizontal force of 10 Newton is applied to a block A. Horizontal force of 10 Newton is applied to the block A, right? The mass of block A and B are 2 kg and 3 kg respectively. The blocks slide over frictionless surface. The force exerted on block A, right? Block A, the force exerted by the block A on the block B will be. Very simple, right? Once you know the common acceleration, right, you can talk about the FBD of individual block and calculate the value of normal reaction on block B. So just go ahead and try to solve it, right? You have a minute or let's say 90 seconds, you can solve it, okay? So try to practice it. You have a 2 kg block, you have a 3 kg block, the whole thing is moving under the influence of 10 newtons. So the concept is very simple. You see that these kind of problems are asked in the NEET exam in block and block problem, right? So we are investing so much time on solving block and block problem, the other block is accelerating and all. Those kind of questions are good. But at this moment, we can drop all of that, right? If you are not very good with those kind of problems already, we can drop all of that. We don't have to worry about all of that because that is not something which is asked repeatedly in the NEET exam, right? They ask these kind of questions. So concept is simple. We can say that acceleration of the whole thing is net force upon total mass, which is 10 upon 5, which is 2 meter per second square. Now consider the FBD of both the things, right? So acceleration is net force upon total mass, okay? When the whole system is moving as one, acceleration will be net force upon total mass, right? All right. Very good. Mallikarjun is giving the answer C. Surya is giving the answer C. Very nice. So let's have a look at that. Huh? All right. All right. So Surya and Mallikarjun both were actually correct. So option C is the correct option, right? And as I have already told you how to go about it, you can simply first calculate the acceleration, which is 10 upon 5, 2, right? Then talk about the individual FBDs, right? So when you look at the FBD of this block, there is no force acting on the right? There is only normal reaction which are acting on each other, right? So this block, talk about the FBD of this block, it has a normal reaction, right? That we have to calculate force or normal reaction acting on the block B by the block A. The whole thing is accelerating with a common acceleration of 2 meter per second square, right? So force is equals to this mass into this thing. So mass of this thing is given 3. 3 into 2 is 6. That's it. 6. Look at this question and try to solve it. You see that in the year 2020, they asked a pulley kind of question. But generally what we do when we try to solve pulley kind of question, we go till like a hell lot of problems. We try to solve it on the pulley. But they don't ask many times. This is called simple Atwood's machine. Right, there's one pulley and 2 masses around it, right? There are not many difficult kind of problems which are asked around it. So let's look at that and try to solve it, okay? So we have a pulley and 2 masses are attached to it. So they are asking you something. So 2 bodies of mass 4 and 6 are tied to the ends of a massless string. The string passes over a pulley which is frictionless. The acceleration of system in terms of acceleration due to gravity is. So what is the correct option? The acceleration of the system in terms of acceleration of the gravity is. So one particle will move down with some acceleration and the other particle will move up with the same acceleration. What will be the value? So we can say that acceleration is net pulling force upon total mass. This is the concept I taught you. Acceleration is, very good Surya, acceleration is net pulling force upon total mass. So we have mg1 m1g minus m2g, which is 6 minus 4 into g upon total mass, 6 plus 4, right? The value of this thing you have to, in terms of g you have to calculate. So 6 minus 4 into g upon 10, which is 2g upon 10, which is g by 5. So option C is correct, right? Option C is correct by default. Very simple. Very good Chaitanya, very good Mallikarjun, right? So all right. So yeah, Mallikarjun, Chaitanya both gave the correct answer, and option C is the correct option, right? Now look at this thing. Here we have a spring, and at the end of the spring we have a thread and connected another mass like this, right? So look at that. We have two blocks A, B of mass 3 m and m. They are connected, right? It is asked in year 2017, right? 2017 may sound recent, but it is not recent. It is around 8-9 years back, right? 9 years back or so. Okay. But anyways, there are two blocks of A and mass A and B. They have the mass 3 m and m, and they are connected by with a massless and inextensible string. Okay, so this string is massless and inextensible. The whole system is suspended by a massless spring as shown in the figure. The magnitude of acceleration of A and B immediately after the string is cut are respectively. Okay. So initially the whole thing is under equilibrium, nothing is accelerating, right? Then what you do is you cut this string. Okay. So when you cut this string, what will happen? The spring is stretched under the entire load. The spring is stretched under the entire load, and when you cut it, some load is removed, right? Some load is removed, and the spring doesn't want to stretch that much. It will go back, right? It will go back. So this is falling freely under the gravity. Once you cut it, it is falling freely under gravity, and this is moving under a net force, right? So what is that value? You have to talk about that, right? So you have to talk about that, right? Think about it and try to solve it. Very good problem, and it will make you think. Okay. You have 2 minutes to think about the problem and solve it. All right. All right. So let's try to have a look at that. So as I said, okay, what we are doing basically, once you cut the string, the second block will be under free fall. So it will be moving freely under gravity. The acceleration will be acceleration under gravity g, right? So second block will have acceleration this thing. So either option A is correct or B is correct, because the other options have some acceleration in the second block, which is not possible, right? You just cut the string, the second block is going to fall freely. So this will have acceleration g. Okay. Now the first block, right? The first block is going to accelerate with a different acceleration. It will move up Why? Because the spring is stretched under the combined load. Now when you reduce the load, the spring will go back like this, right, with the net force, right? So whatever force is remaining, with the remaining force, the spring will go back, right? Yes. So mg is removed, so with the remaining force, the spring is trying to go back. So definitely it does not have the complete acceleration of gravity, right? It has lesser acceleration, right? So by in the first sight, you can directly tell that the option A is the correct option with the common sense, with the just general thinking. But for the sake of solving, you can just go ahead and try to solve it in this way. Consider the FBD of these blocks, right? Before the string is cut. So this is the lower block of mass m, the weight is acting downward and the tension force is acting upward. So weight is acting downward and tension force is acting upward. So tension force T is equals to mg. From this FBD we can tell T is equals to mg. From the upper body we can say that here the kx, the restoring force, is acting upward and the tension force is acting downward, right? So restoring force is acting upward and tension force is acting downward, okay? And also the weight of this thing is acting in the downward, right, which is 3 mg acting downward, right? Okay, so now if you want to write it out, so you can simply say that what will be the kx, right, this particular portion, like from the first FBD, kx is equals to downward forces T plus 3 mg, and T is nothing but mg, so just put it over here. Kx is equals to 4 mg, okay? So before the string is cut, the restoring force was 4 mg. After the string is cut, what is the net restoring force? 3 mg, right? Because mg has been reduced. After this is removed, the restoring force is only 3 mg, right? So now what is the change? What is the net force which is pulling it up? So the net force which is pulling it up is the 4 mg minus 3 mg, which is only mg, right, upon the total mass, the total remaining mass. So once the spring is cut, only the 3m mass remains, which is moving up, right? So mg upon 3m, so m and m will cancel out, the answer will be g by 3, right? So clearly it is the g by 3 acceleration, the remaining mass will move up, right, and the other mass is falling freely under the gravity, right? I hope the idea is very clear. So option A is going to be the correct option, right? Now let's move on and talk about the other question. This is a simple wedge based question, right? So read it. A block of mass 2 kilogram is placed on an inclined rough surface AC of coefficient of friction mu. Coefficient of friction is mu. The net force on the block will be, what will be the net force on the block, right? What will be the net force on the block? Again, it is asked in the year. Just a second. All right. So read the question and try to solve it. Over here, we have this block, we have this wedge and a block is there. Coefficient of friction is also given. Now what is happening? All right. So a block of mass 2 kg is placed on an inclined rough surface as shown in the figure. Coefficient of friction is given mu. The net force on the block will be, what will be the net force on the block, right? Think about it. What will be the net force on the block, right? This is a very easy question, okay? Because you see that one component of the weight is acting downward, right? If the surface was smooth and the block was smooth, it will automatically slide downward. Why? Because one component of the weight is acting this way, g sine theta is acting this way, right? But here the friction force is also there, so friction force is going to oppose it, right? So net force we have to talk about. So mg sine theta minus the friction force, right? Mg sine theta minus mu into mg cos theta. That's it, right? Mg sin theta minus mu mg cos theta. Why mu mg cos theta? Because weight is acting this way, mg. This is mg cos theta, mg cos theta, right? The normal reaction is going to act perpendicular to it. So normal reaction is nothing but mg cos theta. Friction force which acts here is mu into normal reaction. Normal reaction is mg cos theta. So mu mg cos theta is the friction force which acts, right? Mu mg cos theta, this is the friction force which acts, right? So what will be the net force? The downward force is mg sin theta. The upward force is mg cos theta, the net force is going to be mg sin theta minus mu mg cos theta. I hope it is very, very clear. Just put it and you'll get the answer. Okay. All right. So Mallikarjun is saying option D and Chaitanya is saying option B. And okay, let's say that who is actually correct. So the angle is 30 degree, right? Angle is 30 degrees. So here you have sine 30, which is 1 upon root 3. And here you have mu. Mu have 1 upon root 3. And cos 30 is root 3 by 2. Okay. So root 3 and root 3 will cancel out. Try to solve it. Try to solve it. So net force is mg sin theta minus mu mg cos theta. Mg sin 30 minus mu mg cos 30. So just put it, put the values of everything. Sin 30 is 1 upon 2. So 1 upon 2 mg minus mu is 1 upon root 3 and cos 30 is root 3 by 2. So root 3 and root 3 will cancel out. It is half mg and another half mg. Half mg minus half mg is 0. Right. So there is no net force acting on the body right now. Option should be 0. Option B is the correct option, right? Option B is the correct option. Okay. So Chaitanya was correct, right? Option B is the correct option, right? Net force is subtraction of these two things, right? Let's move on and talk about the next question, my dear kids. So it was asked in the year 2023, right? Now the next part of the chapter is circular motion, right? So from the circular motion, generally one question is asked, right? Generally one question is asked, and they ask frequently the question based on motion in a vertical circle, right? So motion in a vertical circle, they ask it multiple times. Okay. All right. Question about motion in a vertical circle, they ask multiple times. So let's move on and talk about circular motion. So let's have a look at this question. A mass M is attached to a thin wire and a word in a vertical circle. The wire is most likely to break when? 2019 में पूछा गया है, right? It is asked in year 2019. So read the question and try to answer it. Very simple question, right? At what angle? So think about it. The thread will break at a point where the tension in the thread is maximum, right? The thread is most likely to break at a point where the tension in the thread is maximum. So at which point the tension in the thread is going to be maximum? So at which point tension in the thread is going to be maximum? Inclined at an angle 60 degree from the vertical, the mass is at the highest point, the wire is horizontal, the mass is at the lowest point. Think about it. When the mass is at the lowest point, think about it, the tension in the weight, because of the weight acting downward, the tension in the rope is going to be maximum. So this is where there are highest chances of the rope being, the breakage of rope. Okay. So option D has to be the correct option, right? Option D has to be the correct option, right? Where is it most likely to break? It is the lowest point, because at that point the tension in the rope is maximum. So option D is correct. Now look at this one. What is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop, right? So this is a ball hanging from a rope, right? I just want to complete the loop, so I'm allowing it to move with a certain velocity, right? I'm starting it with a certain velocity. If the velocity is less, it will move to a certain distance and come back. If the velocity is slightly higher, it will move slightly higher and come back. The velocity will have a minimum required value to move to cross to a topmost point and then complete the circle, right? What is that minimum velocity? Direct question, right? What is the minimum velocity so that it can complete the circle? So clearly it is root 5 gr, right? Root 5 gr should be the minimum velocity at which it can complete the circle, right? Look at this thing. A child is sitting on a swing. Its minimum and maximum height from the ground is 0.75 and 2 meters respectively. What will be the maximum speed? So see that this is the swing, right? The minimum and maximum height, and maximum height, it will go up, right? And of course the swing is going to be certain height above from the ground, right? So this is the minimum height. The minimum height of the swing is basically when the swing is in the mean position, right? That is there in which is 0.75 meters, right? And at the highest point it is 2 meters, right? So this is 0.75, this is 2 meters, right? Respectively, its maximum speed will be. So clearly, due to the fall, it will convert the potential energy into the kinetic energy. And over here, it has minimum potential energy and maximum kinetic energy. Here it will have maximum velocity. Tell me what is that value, right? You can easily tell that what will be that value, right? So you can say that whatever drop of, this is the concept, whatever change of potential energy you are getting, that is going to be the increase in kinetic energy, half mv square, right? So mass and mass will be cancelled out, right? And you can further solve it and calculate it. So the value of g is whatever, right? You can put the value of g. Delta h is 2 minus 0.75 half v square. So half v square. So velocity is maximum over here. That is what you're going to get. So just solve it and you will get the value of velocity from here, right? Just solve it and you will get the value of velocity from here, right? Tell me what is the value coming out? Option D, A. So yeah, you see, right? The value velocity mg delta h is half mv square. So velocity is 5 meter per second. 5 meter per second. So option B is the correct option. Okay. All right. So let's move on and talk about this question. As shown in the figure, a mass is performing a vertical circular motion. The average velocity of the particle is increased. Then at which point will the string break? So at which point the string is most likely to break? So as I said, the string is most likely to break at a point where the tension is highest, right? The string is most likely to break where the tension is highest because it's a vertical circle. At this point, all the weight is acting downward, right? So clearly option B is the correct option. It is going to break at the point B, right? Now, let's talk about the questions on work, energy and power, right? Let's have a look at what kind of questions are asked from the chapter of work, energy and power in the previous year NEET exams, right? What is the trend of the questions, right? What is the trend of the questions? From the work, energy, power, the questions of work, energy theorem are very, very important. Second is the relation of power with force and velocity. That is very, very important. And third is conservation of momentum. Conservation of momentum, you can say that it is from the NLM as well, right? So that is also fine. But generally in some books, collision is a part of this chapter, right? That is also fine, right? So whatever you take, right? Otherwise, these two things you can consider as very, very, very important. Work energy theorem and relation between power and this thing. One more thing that they are asking generally, that is relation between momentum and momentum. P is not power, it is momentum. Relation between momentum and kinetic energy. This is what they ask multiple times they are asking, right? So these are the 4 points that are repeatedly asked in the previous years, right? These are the 4 things that are repeatedly asked in the previous 4 years, right? Okay, have a look at this question and try to solve it. This is the last year question in the year 2025. They ask it. The kinetic energies of two similar cars A and B are 100 joule and 225 joule respectively. Kinetic energy of two similar cars A and B are 100 joule and 225 joule respectively. Okay. On applying the brakes, a car A stops after 1000 meter, B stops after 1500 meters. So clearly, B was moving much faster, right? If FA and FB are the forces applied on the brakes of the cars A and B respectively, and then what will be the ratio of FA and FB, right? Try to solve it. Okay. Try to solve it. Just go ahead and try to solve this particular question. Simple question, right? Okay. So you see that, just go ahead and try to solve it. So what are the concept? So when you're trying to stop the car, let's say that the car was moving initially with the velocity v, and you want to stop it, so eventually the velocity will become 0, right? So for that, you have to apply a force so that it will slow it down and eventually it will stop. So that force is acting throughout the displacement. So throughout the displacement, the force was doing some work, right? So whatever work was done, that was nothing but the change in the kinetic energy that you brought up, right? So by the work energy theorem, we can say that work done to stop the car is equals to change of kinetic energy. Yes or no? Work done is nothing but the change of kinetic energy, right? So in the first car, how much work is done, right? That is change of kinetic energy. So final kinetic energy is 0. Initial kinetic energy is half mv square. So work done is work done is half mv square in the first case. Similarly, in the second case also you can calculate the value of work done. That is nothing but the change in kinetic energy. And if the displacement in the first case, before it stops, this is the stopping distance, let's call it stopping distance is S. So, and the force that was acting, the braking force was F. So how much work was done? The work done was nothing but force into stopping distance S. That is equal to change of kinetic energy delta K, right? All right. So similarly, when two bodies are compared, so change in the kinetic energy of the first one and change in the kinetic energy of the second one is equals to nothing but force 1 into stopping distance of first, force 2 into stopping distance of second. So once you take the ratio, you can solve everything out very, very easily, right? Once you take the ratio, you can solve everything out very, very easily, right? Okay. So put the values over here, right? The value of force, the ratio of FA and FB you have to find out. This is FA and FB. This is the ratio you have to find out. First car has a stopping distance S1 of 1000 meters. The second car has a stopping distance of 1500 meters, right? So you can just go ahead and try to solve it, delta K1 and delta K2, right? You just go ahead and try to solve it. Delta K, the kinetic energies they are directly giving you, you don't have to put the velocities and all. 100 and 225. So this is 100. This is 225. So clearly F1 and F2 we can find out the values of F1 is to F2, right? All right. So this is the value. FA is to F2 comes out to be 2 is to 3, which is correct. Now have a look at this. A particle of mass 5m at rest suddenly breaks on its own into three parts. So now this kind of question is asked multiple times, right? This kind of question is asked where a particle breaks into more than two parts, right? This kind of question is asked multiple times in the previous year NEET papers. A particle of mass 5m at rest suddenly breaks on its own into three fragments, right? So 5m is breaking out into three fragments. Two fragments of mass m each move along mutually perpendicular direction. So you see that it is breaking out into three parts. It has mass m. So one is moving, two parts are moving mutually perpendicular and they are having a mass m, right? So the third mass, 5m was the total mass, m and m is removed, so 3m is remaining. So 3m must move like this, yes or no? So that the resultant of momentum of these two, these two must be cancelled out by the momentum of the third mass, yes or no? All right. So the okay. So with v each, okay. So they are moving with velocity v each, okay. The energy released during the process is, so how much energy is released during the process? So in this process, how much energy is released? Clearly, we can talk about that particular part, right? So here, what is happening? Just think about it, right? I'll just like it's a simple question. So right. So I'll give you 120 seconds to solve it, right? So the question is simple. It is saying that, right, you have a 5m mass, right? And it is splitting out into three fragments, right? So m and m are moving with velocity v and v perpendicular to each other. So the third part, 5m may say we are removing m and m, so remaining mass is 3m. That has to move in such a way that it cancels out the momentum of these two, resultant momentum of these two, right? So thinking about that logic in your brain, you have to talk about the energy released during this process, right? So how much energy will be released? You see that all three particles are moving, right? When mass moves, it has energy half mv square. So when this mass is moving, it has energy half mv square. This mass is moving, it has energy half mv square. And the other mass is moving, it has energy, let's say it has a velocity v dash. So it has an energy half m v square, v dash square. So somehow if you can calculate v dash, you put the v dash over here. So at the end what you will do, the total energy released will be energy of this particle half mv square, energy of this particle half mv square, and energy of the third particle this half 3m into v dash square, right? Just put the get the value of v dash and get this will be the total energy that is released, right? This is the total energy which is released. Just try to solve it and you have your time that is moving, right? The resultant of those two momentums must be the equivalent to the momentum of the third one. So what is the momentum of these two things? We can say mv and mv. So resultant of these two things is going to be root 2 mv. That is being balanced by the resultant of the third body, which is 3 mv dash. The 3 mv dash is equals to root 2 mv. V dash, you can solve it out. It is going to be root 2 upon 3v, right? Simple. Try to solve it. There is nothing more difficult about this particular thing. Think about it. If a body is splitting into three parts, those three parts are moving. They have energy half mv square, half mv square, half mv square, right? Add all of that energy up. This is the energy released during the explosion, right? Okay, try to solve it and answer it in the chat box. My dear kids, we are learning the best questions from the previous year NEET exams, right? And they will definitely help us out in assessing our preparation level, and also they will help us out in preparing well if we are considering a drop year, right? All right. So let me help you with the solution, right? So as I said, these three bodies, this body is splitting into three parts, mv, mv. So the resultant momentum of these two is root 2 mv, right? Root 2 into mv, right? So this one has a momentum equivalent to the other one. They must cancel out each other because before explosion, the system had no momentum. It was stationary. After explosion, the net momentum has to be zero, conservation of momentum, right? So this one is moving with velocity v dash. So momentum of this one is 3m into v dash. That is the resultant momentum of these two, which is root 2 m into v, right? So you see that m and m is cancelled out. So v dash is nothing but root 2 upon 3v. Yes or no? Very simple, right? Root 2 upon 3v. So what is going to be the total energy released in the process? Half mv square plus half 3m into v dash square, right? So just add it up. Half mv square plus half 3m into v dash is root 2 by 3 v square. So root 2 square is 2, 3 square is 9, and then you have v square, right? So you can solve it. 3's are this and this, right? So half mv square is nothing but only mv square, and you have mv square by 3, right? So you have 3 mv square by 3, and mv square by 3 is 4 by 3 mv square. So that's the answer. Option D is the correct option, right? Option D is the correct option. Okay, nothing to worry about. Option D is going to be the correct option. Let's have a look at that. Next one. A body constrained to move in the y direction is subjected to a force given by this, right? A body is constrained to move along y direction. So body cannot move in x and z, right? So the force acting is three-dimensional. It has x component, y component, and z component. Okay. The work done by this force in moving the body through a distance of 10j along y-axis will be. So what will be the value of work done? So the concept is same, right? Concept is same. Work done by the force is force vector dot displacement vector. Force vector is given this, right? It is asked way back, but numerical like this are most likely to repeat because they are moving towards simple conceptual question, right? You see that when you're taking dot product of different unit vector will become 0 and it will become 150. All right. So option A has to be the correct option, right? Option A has to be the correct option. Very good, Mallikarjun. Right. Option A has to be the correct option. Right. Let's solve work done by the variable force as well. Have a look at this question. A force is acting 20 plus 10y. So with the changing value of y, the force will be changing. Okay. It is acting on a particle in y direction. It is acting on a particle in y direction, where F is in Newton, y is in meter. Work done by this force to move the particle from 0 to 1 meter is. What will be the value of work done by this force? So you know the concept is very clear. How to calculate the work done by variable force? You don't call it F dot D anymore. You don't call FD cos theta anymore. Work done by variable force is integral of F into ds, right? From original position S1 to final position S2, right? So here we have a variable force. It is changing with y. So integral F dy, we will do that, right? So whatever value of force we have, we will put it 20 plus 10y, right? 20 plus 10y, and we will integrate it with respect to y, right? And the value of y is changing from 0 to 1. Okay. So we have 20y and 10y square by 10y square by 2. So we have 20y and 10y square by 2, and the limits we have to use 0 to 1, right? So upper limit minus lower limit. At lower limit it is 0. At upper limit it is 20 into 1 plus 5 into 1 square, which is 20 plus 5, which is 25. Option D is correct, right? I hope the idea is very, very clear. Okay. Option D is correct, right? So work done by variable force can be simply figured out like this: integral of FDS, right? Work done by variable force, right? Somehow, for some reasons, in the NEET exam, they ask it multiple times about how to calculate the work done by a variable force, right? Now look at this. We have a force and time curve, force displacement curve that is looking like this, right? Okay, the force is in Newton, displacement is in meter. The work done by the force in moving the object from 0 to 6 meter is 0 to 6 meter is. How much work will be done to move an object from 0 to 6 meter, right? How can you calculate that? Definitely go ahead and try to do it. Work done by the force displacement, like how will you calculate the work done in the force displacement diagram? The concept is same. Concept is same. Work done is integral f ds from S1 to S2. So this is telling you work done between S1 to S2 is area under the curve between S1 to S2. So work done between this place to that place is area under the curve between S1 to S2, right? So just take the area under the curve. Area of trapezium is 1 upon 2 summation of these two sides. So it is 3, it is 6, 3 plus 6 into distance between them 3. So it is 9 into 3 upon 2. 27 upon 2, which is 13 and a half, which is option number B, right? I hope the idea is very, very clear, right? Okay. All right. So let's continue to keep on moving and talk about the next one, right? Very quickly, let's move on and talk about the next one. The next question is talking about the potential energy of a long spring when it is stressed by 2 centimeter is U. When a long spring is stressed by 2 centimeter, the potential energy is U. If the spring is stressed by 8 centimeter, the potential energy will be how many times? So the clearly idea is, concept is what? The concept is potential energy of the spring is half kx square, right? So potential energy is dependent on the square of deformation, right? So previously the deformation is 2. Now the deformation is, you see that, 4 times. Yes or no? 4 times of previous value. So if the deformation is increasing by 4 times, the potential energy will increase by 4 square times, which is 16 times. Yes or no? So U1 upon U2 will be half kx square upon half k. The new deformation is 8 square. So clearly you see that 16u, it should be the answer, but just for the sake of solving, it is 1 upon 16. So you see that u2 is 16 times u1. u2 is 16 times u1. I hope the idea is very, very clear. So option B is the correct option. Look at this question. A bomb of mass 30 kg is rest is exploding into two pieces of masses 18 and 12. The velocity of 18 kg mass is 6. The kinetic energy of the other mass is. So very simple question, right? And you can solve it very, very easily, right? So how can you do that? So concept is, here we are applying the conservation of momentum in this situation, right? The mass is exploding into two halves, right? Before explosion, there was no momentum in the system. Before explosion, there was no momentum in the system. Once the explosion happens, it is breaking into two parts that they are going to move apart like this. One is having a mass of 18 kg, the other is having a mass of 12 kg, right? The velocity of 18 kg mass is 6 meter per second. So velocity of this is 6 meter per second. The kinetic energy of the other mass is going to be, first think about the velocity of the other mass. First of all, their momentums must cancel out each other, because initially the momentum was 0. Finally, the momentum should also be 0. So P1 plus P2 should be 0, or P1 should equals to P2. So we can say 18 M1 V1 must be same as M2 V2. So from here, the velocity of the other body will come out to be 9 meter per second. 9 meter per second, right? All right, 9 meter per second. I hope the idea is very, very clear. And now they are asking about the kinetic energy of the second body. Kinetic energy of the second mass is half mv square. So half kinetic energy, half mv square. So that's it. So it is 6. 9 into 9 is 81 into 6. So it is 6, 486, right? So 486, which is option number B, that is the correct option. I hope the idea is very, very clear, right? Very simple. These kind of numericals are asked in the previous years in the NEET exams, right? A particle of mass m1 is moving with velocity v1, and another particle of mass m2 is moving with velocity v2, right? There are two particles, they are moving with velocity v1 and v2, they have mass m1 and m2. Both have the same momentum, but their different kinetic energies are e1 and a2. What will be the relation between their kinetic energies if m1 is more than m2? My dear kids, the concept is very, very same, right? Here you see that the mass m1 is moving velocity v1, mass m2 is moving velocity v2. They have the same momentum, Think about the kinetic energy in terms of momentum. Kinetic energy is square of momentum upon twice of mass. Now, if momentum is same for both the bodies, kinetic energy is only dependent on mass. And here you can say that kinetic energy is inversely related to the mass. So if momentums are same, so heavier body will have lesser kinetic energy, right? Here first body is heavier, so its kinetic energy will be lesser. So K1 will be less than Ke2, E1 will be less than E2. So option C is the correct option, right? Option C is the correct option, right? Its kinetic energy will be lesser, it's more, right? So not C, sorry. Its kinetic energy will be lesser. Option A will be the correct option, right? So that's the main idea. How can we say that? Let me say it again. So you see that kinetic energy is square of momentum on twice of mass. So you see that if momentum is constant for both of them, so kinetic energy only depends on mass, they are inversely related. So the body with higher mass will have lesser kinetic energy. Here the first body has more mass, that means it will have lesser kinetic energy. E1 will be lesser than E2. E1 is lesser than E2, right? So this is the first correct sign, right? I hope the idea is very, very clear. Now let's talk about some questions from the gravitation chapter, right? Let's talk about some questions from the gravitation chapter, right? So here it is. The question is saying that a radius of Martian orbit means orbit of Mars, right, around the sun is about 4 times the radius of orbit of Mercury. Okay, so this is sun, right? This is, let's say, Mercury closest, and this is Mars. So radius of orbit of Mercury is 1/4 of radius of Martian orbit, right? Okay. The Martian year is 487 Earth days with then, okay. The Martian year is, so Mars takes 687 days to complete one full circle around the sun. Then which of the following is the length of 1 year on the Mercury? So for Mercury, how long the Mercury will take to one full circle around the sun, right? So clearly the idea is very, very clear. So we can apply the Kepler's law, right? We can apply the Kepler's law, right? So concept is same. So the planets which are further will definitely take more time. But Kepler said that the relation between the time period for a planet is this, right? So if the planet is at a distance r from the sun, right, then how much time it is going to take, t, that is going to be related in this manner, that the time taken by the planet to revolve around the sun, t square, the square of time period is proportional to cube of radius, right? One thing is very clear, the planets which are further away will definitely take more time to complete one circle, right? But what is the exact relation between the time period and radius? This is the relation. A square of time period is proportional to cube of radius. So upon solving it, we can say that time period for Mars and time period for Mercury is radius of Mars and radius of Mercury. But one very specific relation is there, right? These powers are there, right? So time period for Mars is 687 Earth days, yeah, correct. And time period for Mercury we don't know. Time period for Mercury we don't know. Let's call it Tm, right? Radius of Mars is 4 times radius of Mercury. So clearly, let's take the cube on the whole thing, okay? And we are saying that the radius of Mars is 4 times radius of Mercury. So if radius of Mercury is Rm, so it is 4 times Rm. So that is cancelled out, it is 4 cube. So simply it is 687 upon a square of Mercury time period, it is 4 cube. So just solve it. Tm square is nothing but 687 upon 4 cube. It is 64, right? 4 cube is 64, right? So solve it. So and then take the under root and you will have your answer, right? So yeah. All right. So solve it and you will have your answer. All right. I hope there is nothing calculation is mistake that we have done. So this is how it is. This is the ratio of time period is same as ratio of this thing, right? Okay. So time period for Mercury, time period of Mars, radius of Mercury, radius of Mars. So yeah, we know that radius of Mars is 4 times. So here you have 4 over here, right? So it is 1 upon 64. No problem with that. Time of Mercury comes out to be under root of those things. So it is 1 upon 8. Okay, time of Martian upon 8. So, okay, time of Martian upon 8. Oh, so we have done little calculation error over here. No problem with that, right? We can correct it, right? So we can correct the calculation error. We can say that time of Mercury is under root the whole thing, because here we have the square as well, na? Here we have the square as well. Time of Mars, we are not using the square. So you see that time of Mercury is squared, time of Mars is also squared, na? So there is a square over there as well, right? So now when you are going to write down time of Mercury is going to be 687 square upon 4 cube, and now the under root is there, right? So no need to worry about that. Under root is there and a square is there, so 687 will be there, right? And 4 cube is there, which is 64. Under root of 64 is nothing but 8. So 687 by 8 is the answer, right? This is the thing, okay? All right. I hope the idea is very, very clear. We have done silly mistake, but no problem. I hope we can solve it again, right? So let's continue and move about the next thing. So you see that in the year 2025, the question from the Kepler law was asked. Kepler law is a very good concept to know, right? And you can just go ahead with it, right? Kepler law is something you can never miss in this particular chapter, right? Now, let's look at this particular question. A planet is moving along an elliptical orbit which is closest to the sun at a distance r1 and farthest away at a distance r2. If v1 and v2 are the linear velocities at these points respectively, then what will be the ratio of v1 upon v2? Think about it. What will be the ratio of v1 upon v2? Right. You can also link it with Kepler's laws, right? Law of aerial velocities and all, right? But I'll suggest you to think in terms of conservation of momentum, right? When the planet moves around the sun, its linear momentum remains conserved. Why? Because there is no net force. Think about it. You say that force is rate of change of momentum, right? If the net force is 0, the rate of change of momentum is 0. If momentum change is 0, that means momentum is constant, right? So when the planet is moving around sun, nobody is pushing the planet from outside. Yes or no? So there is no external force that can change the momentum of the planet, right? So if the planet is in an elliptical orbit around the sun, you know that at a point over here, the velocity is v1. At a point over here, the velocity is v2. So the velocities are not same, but the momentum stays the same, right? Such that the area swept by the line joining the sun and planet always remains same. The areal velocity is always same, right? So yeah, think about it in those terms and the concept you can apply, right? You can say that when the planet is moving around the sun, right? So this is the velocity v1, this is the velocity v2. So what stays constant? The momentum stays constant. What stays constant? Momentum stays constant. So we can say momentum, or you can say m1 v1 r1 stays same as m2 v2 into r2, right? This is the angular momentum, right? That does not change, right? Angular momentum will not change because the particle is covering like this and at an angle, so angular momentum is going to be same, right? m1 v1 is linear momentum, so linear momentum into distance is angular momentum over here, right? Angular momentum over here when it is at distance r1, and here it is at a distance r2. So what will be the angular momentum over here? m2 v2 into r2. So here m1 v1 r1, the angular momentum at this place must be same as angular momentum at the other place. Think about it, right? What will be the ratio of velocities? So clearly we can say the mass of the planet is not going to change. m1 and m2 is same, right? The mass of the planet is not going to change. So the ratio of velocity is definitely depend on ratio of distances only, right? So m1 and m2 is same. So v1 r1 is same as v2 r2, right? So v1 upon v2 is nothing but r2 by r1. Yeah, right, r2 by r1. So option B is the correct option, right? Option B is the correct option. Okay, I hope there is no confusion about this particular part, right? Look at this particular question. In year 2022 is what it was asked, right? Again, it's a very frequently asked format. A body of mass 60 gram experiences a gravitational force of 3 Newton. 60 gram is the mass, it is experiencing gravitational force of 3 Newton. So when placed at a particular point, the magnitude of gravitational field intensity at that point is going to be. So try to answer it, right? Think about it. The question is framed in a way that it sounds very difficult, but it is not, right? Question is framed in a way that it sounds difficult, but it is not. First of all, tell me, what is the gravitational field intensity? What is intensity of gravitational field? Gravitational field. What do you understand by that? This is our planet. What is the gravitational field intensity over here? So you see that near any mass, planet is a mass. Near any mass, there is a point P. So at the point P, the gravitational field intensity is the force applied by the mass toward itself if we place a unit mass over here, right? So force acting per unit mass is the gravitational field intensity over here, yes or no? So let's say that if you are placing a mass m, small m, and this is the mass capital M. So what is the force acting between them? It is g m1 m2 over r square. R is the distance between them, right? This is the total force. This is the total force, right? And what is the gravitational field intensity? It is the force acting per unit mass over here. So force acting per unit mass you can take out over here. So force acting per unit mass is gm over r square, right? This is what? Gravitational field intensity of gravitational field Ig over here, okay? Gm over r square. So I hope the idea is very, very clear, right? So simply what you need to do is you need to think about the force acting at that place on the mass and m over here, right? So clearly they are telling you a body of mass 60 gram is experiencing a gravitational force of 3 Newton somewhere, right? So the body of 60 gram is placed over here and it is experiencing a certain force. What is that force? 3 Newton, right? What is that force? 3 Newton. So the value of force it is experiencing over here is 3 Newton. and the mass of the body is 60 grams. So 0.60 kilograms, right? 060 kilograms, right? So that is there, right? This is the value of gravitational field intensity over here. So anyone who knows the definition of what is gravitational field intensity can solve it. Anyone who knows the definition of gravitational field intensity can solve it, right? Force upon mass, right? So 3 upon 0.60, that is the answer, right? 3 upon 0.60 is the answer, which is 50, right? Let's move on to the next one. An object of mass 100 kg is falling from a point A to B as shown in the figure. It is falling from point A to B as shown in the figure. The change in its weight corrected to the nearest integer is. So definitely when the fall is appreciable because it is falling half of radius of earth. So the value of g will change reasonably in this fall, right? The value of acceleration due to gravity will change reasonably in this fall, right? So when that happens, the change in the weight corrected to the nearest integer. So clearly, what will be the value of g in terms of height over here? What will be the value of g at this new place over here? Just take the difference, right? And it will tell you the final value, right? So think about it. Think about it. We are talking about the weight, change in weight, right? So what is weight? Weight is nothing but m into value of g at that place, right? So value of g at that place from the height was initially 2re, height was initially 2re, right? I hope that is very, very clear, right? So just put the value of g over here. So you see that value of weight at point A is m into g at point A. So what is the value of g at a certain height? We can say g at a certain height is g re upon re plus h ka whole square. This is the basic formula. G at a certain height. How does the value of g changes with height? It is g re upon re plus h whole square, right? So now you know that height of the point A is 2re. Height of the point A, HB is 2re. So just put it over here. And the value of weight at A, you can find out mg upon 9. Now, the weight at B is clearly m into g at B. G at B is nothing but mg re upon re plus height of B ka whole square. So clearly you can put it mg re and hb is nothing but 2re minus re by 2. 2re minus rb by 2. This height hb is 2re minus re by 2, right? So it is 3re by 2. Okay. So basically re plus 3re by 2, right? Height from the ground. Okay. It is 4 mg upon 25. So clearly the weight at B you have figured out. So just take the now you have to talk about what is the difference in the weight you are getting. So just subtract these two things and the difference of the weight is 49 Newton. Difference in the weight is coming out to be 49 Newton, right? So decent question, but slightly lengthy question, right? So if you get these kind of questions with a lot of calculation, we will keep these questions for the last, right? Okay, so there are two bodies and both the bodies are, there are two situations where we are going to get new values of weight, right? Weight, okay? And the difference is figured out in that way, okay? Let's move on and talk about the next one. At what height from the surface of Earth, the gravitational potential and the value of g are this and this respectively. The radius of Earth is 6400 kilometers. Think about it, right? So this is the numerical, you can solve it, right? This is the numerical, you can solve it. I can give you a minute to solve, right? At what height from the surface of Earth, the gravitational potential and the value of g are this. So gravitational potential is given, right? And the value of a small g are given. So clearly it is not 9.8, it is not at the surface. The body is at a certain height from the surface, right? So at which height we have this small g and this is the gravitational potential at that height, right? The radius of Earth is 6400 kilometers, right? So gravitational potential is gm upon r plus h, right? The gravitational potential is gm upon r plus h. Yes or no? Yes or no? So I hope the idea is very, very clear. Right. And the value of g with height is gm upon re plus h ka whole square. Is that clear? Right. So at what height we are getting these things? So yeah. So just solve it. You have the ratios given to you, right? And you can further solve it, right? So you see the value of gravitational potential is this gm upon re plus h. And the value of acceleration due to gravity with the height is this, gm upon re plus h whole square, right, in terms of mass of earth, right? So once you try to put it, right, you see that in this expression, if we multiply and divide by re plus h, if you multiply and divide by re plus h, if you multiply and divide by re plus h, right, if you multiply and divide by re plus h, come on, right? So what will happen? In the numerator, we will have gm into re plus h, and the denominator we have r plus h whole square, right? So denominator, just look at this part, gm upon r plus h whole square. So gm upon r plus h whole square is nothing but gh, right? So you can just put it, right, and solve it. So you can relate between these two things. You can relate between these two things, okay? All right. So this is how you can relate these two things, and the variation, the relation between, so from here you can write it out. Why postpone it for future? So it will come out as r plus h upon this whole thing, gm upon r plus h whole square is nothing but gh. So over here what is written, r plus h, this part is vh upon gh, this, right? This is what we have written, right? So you can further solve it and get the value of height, because height is something they are interested in, vh upon gh minus r. So this is the expression, right? This is a very useful expression, right? It relates two things, right? It relates two things. At a certain height h, what will be the relation between potential and acceleration due to gravity at that place? So v upon g minus r, right? V upon g plus r basically, right? So just solve it, because minus and minus will add up, and this is going to be the final answer, right? I hope that is very, very clear, right? Now the ideas are about rotation, right? Let's talk about that part. In the case of rotation, there are a lot of difficult concepts, right? So in the case of rotation, there are a lot of difficult concepts like toppling. There are concepts like rolling motion, right? But if you analyze the previous year papers, the difficult concepts are not asked that much, right? Your focus right now in the case of rotation, if the rotation is not very, very strong topic for you, right now you should focus on some key ideas like terms of rotational motion, angular velocity, angular acceleration, those things about the rotational motion, right? Few basic things, terms of rotational motion, and only two more ideas, moment of inertia, right? Radius of gyration, radius of gyration, all right. And at last you have one more thing, moment of inertia, radius of gyration, and you have parallel and perpendicular axis theorem, These ideas are mostly asked from the rotation chapter, and if you are somebody who is not very confident with this chapter, my dear kids, you can do only these things, because generally the questions are asked from these parts, right? Okay? So without any further delay, let us start solving the questions for the first part, which is about the terms of rotational motion. It is asked in the year 2024, right? Look at the question and try to solve it. Omega 1, omega 2, omega 3 be the angular speed of second hand, minute hand, and hour hand of a smoothly running analog clock. So we have the analog clock. It has the minutes hand, it has the seconds hand, it has the hours hand, right? So all of them will take same same angular displacement, but all of them will have different time to complete the same angular displacement. So the angular velocities are different for all three of them. The hour hand will take 12 hours, the minute hand will take 60 minutes, which is 1 hour, and seconds hand will take only 1 minute to come back to the same place and complete one full 360-degree rotation, right? So R hand of smoothly, and then what is happening, x1, x2 and x3 are their respective angular distances in 1 minute, okay? Then the factor which remains constant is, which factor remains constant, right? There are three hands, which are minutes hand and seconds hand and hours hand. So which factor remains constant in this particular situation, that we have to talk about, right? So think about it, which factor is going to remain constant in these particular situations? Hmm? All right. Think about it, because we are talking about 1 minute, right? The x1, x2, x3 are distances travel in 1 minute. So if you think in terms of minute, for the seconds hand, let's call the angular velocity is omega 1. Let's call the omega 1, omega 2, omega 3 are for the second hand, minute hand, and omega 3 is for the hour hand. So omega 1, what is the angular velocity per minute? In 1 minute, it will come back, right, to the initial position. So 2 pi by 1. This is the radian per minute, right? What is the angular velocity of the minute's hand? So 2 pi is the angular displacement. But how much time it is going to take? 60 minutes. So radian per minute. All right. And similarly, omega 3 is 2 pi upon 12 into 60, which is for the third one. Right. These are the three clocks you have, right? Omega 1, omega 2, and omega 3, right? So if you try to find a constant across all three of them, so we can say 2 pi, 2 pi, 2 pi, their angular displacement is a constant, right? So, right, if x1, x2, and x3 are the respective angular distances in 1 minute, right? So angular displacement, you know the angular velocity, right? Angular displacement, we are calculating everything per minute, right? So angular velocity will be x1 will be omega 1 into 1 minute, x2 will be omega 2 into 1, x3 will be omega 3 into 1, right? Yes or no? So you can definitely get the value of x1, x2, and x3, and the relation between omega 1 upon x1, omega 2 upon x2. From there we can calculate. So yeah, definitely go ahead. Omega 1 is 2 pi by 1, omega 2 is 2 pi by 60, and omega 3 is 2 pi by 12 into 60, right? This is how fast the hands are moving, right? Now x1 is the distance it is traveling per minute, right? So you don't have to put it in the degrees, right? You can definitely go ahead and move calculate in terms of radians, right? So 2 pi upon 2 pi per 2 pi upon 1, right? And then x2 2 pi upon 60, and x3 2 pi upon this, right? So now by above values, omega 1 upon x1, omega 2 upon x2, omega 3 upon x3, 2 pi upon 360, which comes out to be k, right? 2 comes out to be k, and that is the constant. Okay, so this ratio comes out to be constant. Omega upon k comes out to be constant. If that part is confusing you, don't have to worry about any of that. X1 you can calculate omega 1 into 1 minute, right? X2 you can calculate omega 2 into 1 minute, right? And x3 you can calculate this omega 3 into 1 minute. Okay, how far they will travel in terms of radians, right? So angular distances you will travel, right? So omega 1 upon x1, omega 1 upon x1, same value. Omega 2 upon x2, same value. Omega 3 upon x3, same value. It will turn out to be 1 only, right? So that ratio will come out to be same, and that is equals to k. Okay, so anyways, you can go ahead and try to solve it, right? And let's move on and talk about the next one. The angular acceleration of a body moving along a circumference of a circle is, what will be the angular acceleration of a body which is moving along a circumference of a circle, right? So what will be the angular acceleration of a body which is moving along circumference of a circle? Try to think about it and try to solve it. Along the tangent to its position. So it is moving along the circumference of a circle, along the tangent to its position, along the axis of rotation, right? See that this is the linear acceleration, this is the centripetal acceleration, right? We are not asking about any of that. We are asking about angular acceleration. Think about it. It is along the tangent. No, along the tangent we have axial acceleration or tangential acceleration, right? Along the radius, right, we have centripetal acceleration, right? Away from the center and towards the center, it is centripetal and centrifugal things. So we don't have these things. So it is along the axis of rotation. Clearly, you know that the value of omega and acceleration is perpendicular to the axis of rotation. Yeah, perpendicular to the plane, right? Along the axis of rotation, right? Yeah. So option B is the correct option. Now think about the torque and all, right? So you have the torque acting on the body, which is torque acting. We have to calculate the torque acting on the body force is 3J Newton. The force acting on the body is 3J Newton, right? And the position vector is 2K, right? 2K, right? The place where the force is acting, the position vector of that place is R vector is 2K cap. Now, to calculate the torque, you have to take the cross product of R cross F. Yes or no? So just take the cross product of these two things. Very easily you can go ahead and try to understand that particular part. So it is R cross F. So 2K into 3J. So you know that what will be K into J? It is K into J is minus I. Yes or no? So if you think about it, it is I, J and K. So if you go like this, the next parameter will come up. I into J is K, K into J is I. And if you go in the opposite manner, minus sign will come up. So K cross J, we are going in the opposite manner. So negative I will come up. J cross K, positive I will come up, right? So K cross J, negative I comes up, and this is your answer. The moment of force is this, about a point at the force is acting at this particular point, about this particular point. Okay, so okay, the thing is, this is how the axis is, right? The moment of force which is acting at this point about another point, right? So force, there is another point like this, okay? Moment, the force is acting in a three-dimensional direction like this. Let's say the force is acting like this. So it has some x component, y component, and z component, right? There is another point at which the force is acting, and we are calculating the momentum about another point, right? So we can definitely go ahead and try to talk about that. We can definitely go ahead and try to talk about that. How? Let's understand that, right? Let's understand that. You see, the force is acting at this point, and the position vector of this the coordinates of that particular point are given. But we don't have to calculate the we don't have to calculate the momentum about the origin, right? There is another point A. We also know the momentum of that particular. We also know the coordinates of that point, and we have to take the momentum of force about this point, right? So what part is useful for us? We can say that in this situation, this is useful for us, right? Force and this vector, right? Force vector and this vector, right? So clearly we know this is the point, right? And this is the force which is acting over here, right? So we can draw the position vector of this point. We can draw the position vector of this point, right? So let's say that the force is acting at this point, which is 2 0 minus 3. Let's call this thing is 2 0 minus 3. It is not going to be there. It is going to be somewhere else. So this vector is going to be 2i 0j and minus 3k. This vector, the point about which we have to calculate the momentum, is 2 minus 2 minus 2. This point is not going to be here. It is going to be somewhere else. But 2 minus 2 and minus 2i, that's the thing. So this vector is going to be 2i cap minus 2j cap minus 2k cap, right? If you subtract these two vectors, you will get the required vector like this, okay? And just multiply it. This vector minus this vector is the displacement vector we are talking about, this one, right? Okay, so understand it one more time. This is the force, right? And we want to calculate the momentum of the moment of this force about this point, right? So clearly we need this vector and the force vector. So force vector and r vector, right? But right now they are not telling you r vector directly. They are telling you the force. They are not telling you. They are giving you the value of force vector. They are not telling you the r vector directly. Instead, what they are telling you, they are increasing one step, right? They are telling you the idea about this point where the force is acting. So by knowing the coordinates of that point, you can write down the position vector of this point, this vector. So it is x1, y1, z1. So this will be x1 I cap, y1 j cap, x1, y1, z1. So this will be x1 I cap, y1 j cap, and z1 k cap, right? And this vector, this point about which you have to calculate the momentum of the force, they are not telling anything about that except the coordinates of that point, which is x2, y2, z2, right? So the position vector of that point will be calculated x2 I cap, y2 j cap, and z2 k cap, right? What was required? R vector and f vector. That was the only thing required to calculate the moment of the force, right? But the r vector was not given. Coordinates of endpoints was given. So by knowing the coordinates of endpoint, we can get the value of r vector. How? R vector will be this minus this. So it is x1, x2 I cap, y1, y2 j cap, and z1, z2 k cap, right? This is the value of r vector. Once you know the r vector, you can take the cross product with the f and you will get the value of moment, right? I hope the idea is very, very clear, right? Now let's talk about the equilibrium of a rigid body. So here what is happening? When we talk about a rigid body like this extended object, okay? If we are talking about a point for that matter, right? The equilibrium of point means we only need few things. The net force on the point in every direction has to be 0, right? And the point will be in equilibrium. But when the point, we are not interested in the point, we are interested in real bodies, right? Even if the force is 0, think about it. I'm applying a force of 10 Newton at this end and 10 Newton at the other end, right? So the net force on the body is 0, right? Net force on the body is 0. One is acting up, other is acting down. The net force is 0, right? But the net torque is not 0, right? Because the whole thing will rotate, right? And it will have angular, it will have some angular velocity and all, right? So we can say that in that situation, there is some net angular acceleration that will come into the picture because of that torque, that moment of this thing, the couple, right? So we can say that an extended object can only be under equilibrium when not only the net force in all direction is 0, but also the net torque about every point has to be 0. The body must not accelerate, have any angular acceleration as well as any linear acceleration, right? That's the idea of the equilibrium of the extended objects, right? So what is really happening? We have an extended object, right? And the distances are given from this particular point, okay? This is given 20 centimeter, this is given 40 centimeter, this is given 160 centimeter, and we want to calculate few things, right? We want to know that a uniform rod of 200 centimeter and a mass 500 gram is balanced on a wedge at 40 centimeter from the mark, okay? 40 centimeter. So it is balanced from 40 centimeter, okay? So we have a heavy rod and it is balanced at this point. So clearly the heavier side is over here, okay? So a mass of 2 kg is suspended from the rod at 20 centimeter from the other unknown mass small m, okay? So this is at 20 centimeter mark, this 2 kilogram is suspended. This is 0, okay? This is at 20 centimeter mark. Here 2 kilogram is suspended, okay? Right, and another unknown mass m is suspended from the rod at 160 centimeter mark. So from here at 160 centimeter, another mass is suspended. Okay, sorry. So what is really happening? Find the values of m such that the rod is under equilibrium. So the mass m should be such that not only the net forces are 0, but also the torque about this point has to be 0. Then only the whole thing will be under equilibrium. Otherwise, the whole thing will not be under equilibrium, right? So for that to happen, we can say that the torque created by the weight of this thing, which is mg, 2 into g, let us say, is 10, and the distance about this point, the whole thing is 40, right? This thing is 20, so the remaining thing is 20. So this thing, weight is 20 into distance 20, the torque created on this side is 20, and the torque created on the other side is mg, right? And that distance is what? This is 40, this is 60, 160, so the remaining is 120, right? So mg into 120. So they must be balancing each other. But one more thing is there, that the rod also has its own mass, which is 500 grams. So it will act exactly at the middle. So the whole thing is 200 centimeter long. So it will act at 100 centimeter from this end. So from the point where we are calculating the equilibrium, so it is at 40, the center is at 100, so the remaining distance is going to be 60. So 500 grams means half a kilogram, which is half into g. So that much weight, that much mass, and that much weight is basically trying to turn it in this way. So this and this, they have a turning effect in this direction about this thing, and this thing has a turning effect in this direction about this thing. So they must be balancing out each other. So the 20 into 20 must be balancing out this whole thing, which is what? 5 into 60 plus mg into 120. So solving it will give you the value of mass, right? Simple one equation is there and you have to get the value of mass, right? So these kind of questions are very, very simple. Just you have to calculate the torque about any point, and every force that is acting on the body, you have to calculate the torque of that force. What is the silly mistake that happens in these kind of questions? The silly mistake in these kind of question is, these kind of question is, what we don't do or what we generally skip is the moment of the torque, right? Moment of the mass of the rod itself, is generally skipped. All right. So don't skip that part, because the rod also has some mass. So it also wants to keep a turning effect. So we have to consider the turning effect of that mass, that weight as well, right? So considering everything, you can solve these kind of questions as well and get the value of mass, right? So yeah, this is it. These are only two parts, right? And you see that mg into 100 into 40, that is 60 only. Turning effect of weight, turning effect of mass m, right? And that is being balanced, m you will get over here, right? Now the moment of inertia is there, right? We have a body, we know the moment of inertia of this body. So what is there? The radius of gyration of a solid sphere of mass 5 kilogram about xy is 5 meter. Okay, the radius of gyration is 5 meters as shown in the figure. The radius of a sphere is 5x upon root 7. The radius of a sphere is this is sphere. The radius of a sphere is 5x upon root 7. Okay. Then what is the value of x? So the radius of gyration about this axis is given, right? And the radius of this sphere is also given. So we need to know the value of x, right? So clearly we can go ahead and talk about this particular part, right? We can clearly move ahead and talk about this particular part, right? Okay. So radius of gyration, moment of inertia, if you have to calculate the moment of inertia about this axis, you have to calculate. You can easily do that, because you know the moment of inertia about its own axis, 2 by 5 mr square, right? And this is at a distance r away from it. So you know that by parallel axis theorem, the moment of inertia about this new axis will be 2 by 5 mr square plus mr square, plus mr square. So it is going to be 7 by 5 mr square, right? So moment of inertia about xy is going to be 7 by 5 mr square without any problem, right? By parallel axis theorem, you can say that by parallel axis theorem, moment of inertia about this xy is moment of inertia of the body about the centroidal axis plus m into distance between these two axes ka square. Distance between them is r, so it is square. So it is 2 by 5 mr square because we have a sphere. So it is going to be 7 by 5 mr square, right? No problem with that. So about this axis, the moment of inertia is going to be 7 by 5 mr square. Yes or no? About this axis, the moment of inertia is going to be 7 by 5 mr square, right? Okay. All right. So the radius of gyration of a solid sphere of mass 5 kilogram about the xy is 5 meters. Radius of gyration about xy is 5 meters as shown in the figure. The radius of the sphere is 5x upon root 7. Then what is the value of x, right? So now we have to think about it. What is the radius of gyration? If the radius of gyration is assumed to be k for any specific distribution of mass, if the radius of gyration is assumed to be k, then mass into square of radius of gyration must be equals to moment of inertia about that specific axis, right? So if about xy axis radius of gyration of this geometry is k, then m into k square must be equals to the moment of inertia about that axis. Okay, this is the definition of moment of inertia. Ixy is coming out to be 7 by 5 mr square, 7 by 5 mr square, right? This is m, and radius of gyration comes out to be 5 about that axis. It is given in the question. It is 5 meter, right? So 5. Mass is cancelled out, right, from here, and you can get the value of radius from here, which is this. Radius square is 5 square into 5 upon 7, right? 5 square into 5 upon 7. Yes. So radius will be under root this whole thing, So under root this whole thing 5 will come out and under root 5 by 7 will be there. Right? So you see that when you compare it, 5 upon root 7, 5 upon root 7 is there. And in place of x, you have root 5 there. Right? So root 5 is the answer. Option D is the correct option. Right? Root 5 is the option. Option D is the correct option. I believe the idea is very, very clear. Right? Simple question. And these kind of questions are there in this particular part. So my dear kids, I will tell you again, if the rotation is weak for you, right, do two things. Don't start rotation right now, right? Consider it that it will take a lot of time and the ROI is not that good, right? The return on investment is not that good, right? I'll suggest you to keep the rotation for the last, right? Or avoid it for now, right? But if you know the basics, I'll tell you, like, don't avoid it completely as well, because there are certain concepts that I have already told you that these concepts are very, very basic, right? So those concepts you can cover, and the list of the concepts that you need to cover, I have written over here, right? If you don't know most things about rotation and you know these things, you will fare well. All right. Okay. Let's talk about the other problems. Yeah. The ratio of radius of gyration of a solid sphere of mass m and radius r is about its own axis to the radius of gyration of thin hollow sphere, thin hollow of same mass, and radius about its own axis is going to be. So what will be the ratio of their radius of gyrations? You might not remember the values of radius of gyrations, but you know I believe you do remember the radius of the values of moment of inertias, right? So it is as I said, 2 by 5 mr square and 2 by 3 mr square, right? These are the values. When you solve it, it will be root 2 by 5 r, the radius of gyration for the solid, and root 2 by 3 for the radius of gyration for the root 2 by 3 r is the radius of gyration for the hollow sphere, right? So looking at the values k1 upon k2, these are nothing but just the pure expertise on these topics. You can go ahead with that. Root 2 by 5 r and root 2 by 3 r, right? So root 3 by 5 will be the answer, right? So all right. So basically none of the options is actually correct. Theorems of perpendicular axis and parallel axis, right? So let's go ahead and talk about this particular part. The ratio of now parallel axis theorem and perpendicular axis theorem, this is going to be very, very important, and they are consistently asking it from the multiple times, right? So have a look into this particular part, right? Try to solve it. The ratio of radius of gyration of a thin uniform disk about an axis passing through the center and normal to the plane to the radius of gyration of the disk is about its diameter is. So what will be the ratio in this particular situation? Try to solve it. You see that the questions on radius of gyration are very, very important, and I have already flagged it, right? Don't read every topic of this particular chapter. Rotation is a huge chapter. Whatever topics I have given you, must do those particular topics, right? This is the last numerical of this class, by the way, right? This is the last numerical of this class, by the way, right? So radius of gyration of thin uniform disk, the ratio of radius of gyration of a thin uniform disk about an axis passing through the center and normal to the plane to the radius of gyration of the disk about its diameter. Okay, think about it. So these are the values you already know. If you don't know the radius of gyration, you can first calculate you can first write down the moment of inertia and equate it with mk square and calculate the value of k. K is the radius of gyration. So that is something you can do in fraction of a minute, right? Let's say 10 seconds you can invest, and quickly you can calculate the radius of gyration, right? So very quickly you can do that without any further problem. So radius of gyration in the first case is r upon root 2. If you don't know that, you can definitely go ahead with moment of inertia. And the second case, radius of gyration is about this thing, right? K dash is this r by 2. So the ratio comes out to be root 2 is to 1. So it's a directly memory based question, right? Now this question is again, one question is there, again it is there. So from a circular mass m and radius r, an arc corresponding to 90-degree sector is removed. The moment of inertia of the remaining part of the ring about an axis passing through the center of the ring and perpendicular to the plane of the ring is k times mr square. Then what is the value of k? Okay, so this is the ring, right? You are removing certain part of it. Okay, you are removing a certain part of it. The moment of inertia remaining part of the ring. This is the ring, and you are removing a certain part of it, which is subtending angle of 90 degree. So this sector is removed from it. The remaining sector is there, and you want to calculate the moment of inertia of the remaining sector. For the whole thing, it is mr square. For the whole ring about the axis, the moment of inertia is mr square. For the remaining sector, once you remove it, the remaining sector, this much, the remaining other part is removed. For this part, the moment of inertia is k times mr square. You want to know the value of k in this situation. So again, very, very simple stuff. Once a part is removed, how can you calculate that? Right. So you see, moment of inertia of the removed part, mr square, and 1/4 is removed in this particular portion, right? So it is mr square by 4, right? So you see that k times mr square minus mr square by 4 is 3 by 4 mr square, right? And this is the moment of inertia of the remaining part, but it is equals to k times mr square. So you see that instead of k, you have 3 by 4, which is the final answer, right? So that's pretty much everything about this particular class, right? I hope we have solved around 50 problems or so, right? And okay, I guess just let me check first. 2-3 problems from center of mass are also there. So let's quickly do those as well. So there are two objects of mass 10 kilograms and 20 kilograms respectively. They are connected to the two ends of rigid rod of length 10 meter, right, with negligible mass. My dear kids, from center of mass, simple kind of numericals are asked, right? Like the center of mass position, right? m1 x1 plus m2 x2 upon m1 plus m2, right? Y position of center of mass m1 y1 plus m2 y2 upon m1 plus m2, right? And position vector of center of mass m1 r1 plus m2 r2 plus and so on upon m1 plus m2, right? These kind of problems are asked multiple times. Look at this particular thing. You have two objects, you know their locations, you have to calculate the center of mass, right? So simply you can do that. X position is m1 x1 m2 x2. Just put the values of those objects and you will get the location of center of mass. Nothing really very serious about this particular thing, right? Similarly, you can go ahead and talk about this one. 5 kilogram object, 10 kilogram object is there, right? And they are attached to this particular thing. The center of mass of the system from the 5 kilogram particle is nearly at a distance of. Similar kind of problem is there. It was asked in year 2020, right? Again, if you think in terms of the problem, masses are given m1, m2, and length is given 1 meter. So the x location of center of mass is going to be m1 x1 by m2 x2 upon m1 plus m2. Just put the values and you will have the answer 2 by 3, right? Again, there are three masses m1 x1 m2 x2 m3 x3. Three things will happen, right? So there are three masses, 300 grams origin, 500 grams at x equals to 40, 400 grams x equals to 70. The distance of center of mass from the origin is going to be, the distance of center of mass from the origin is going to be m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3. No problem with that, right? Just add it up and you will have your answer 40 centimeter, right? Similarly, you have two bodies, 1, 3, and they have the position vectors given to you. So m1 r1 plus m2 r2 upon m1 plus m2, right? The fourth formula that I have told you. You have to talk about the center of mass of the position vector for the center of mass. So position vector for the center of mass will be m1 r1 plus m2 r2 upon m1 plus m2. Same things, right? So same things you have to do. m1 r1 m2 r2 upon m1 plus m2, right? So this is the position vector of center of mass you can figure out, right? At last, you have consider the system of two particles having the masses m1 and m2. Particle of mass m1 is pushed towards the center of mass of the particle through a distance d. By what distance would the particle of mass m2 be moved so that the center of mass of the particle remain at the original position? So slightly better kind of problem, right? We are moving the particles, right? If you are moving one particle in the system, the center of mass will also move. But we don't want the center of mass to move, the other particle has to move as well, right? So how can you do that, right? So you can say you will form two cases. In the first case, you will have the center of mass m1 x1 m2 x2 and m1 m2. No problem with that, right? And here, when the first mass is displaced by distance d towards the center of mass, if there are two particles, this is the center of mass, this particle is moved closer to the center of mass. Originally it was x1, right? You move it for the distance d, so the remaining distance is how much? X1 minus d, right? Okay, so the other particle has to be it has to move closer towards the center of mass again, right? So now think about it, to keep the center of mass wherever it is, so the new location is this x2 plus d2, right? So from here just solve it, and the value of d2 has to be figured out, right? At last you have this thing. There are three identical metal balls, each of radius r. They are placed touching each other on a horizontal surface, right? And they are forming an equilateral triangle. Okay, they are forming an equilateral triangle. Okay, they are placed touching each other on a horizontal surface. Okay, they are forming a, like one ball is placed like this, other ball is placed like this, the other ball is placed like this. Okay, the center of mass of the system is located at the line joining the center. Okay, of course, the center of mass is located at where? So you see, once you join them, these are the three particles, and the center of mass you have to find out. So you see that the center of mass will be located at centroid of this system, right? Centroid of the equilateral triangle. This is the equilateral triangle, right? You can imagine this whole thing is located at the center of mass. This is the entire mass over here. This is the entire mass over here. This is the entire mass over here. So we have three particles. The center of mass of these three particles will be at the centroid of the triangle, right? At 2h by 3 from the top, right? So I hope the idea is very, very clear. We are pretty much at the end of this slide. So from center of mass parts, generally one question is asked, but not very frequently, right? So if you have not covered center of mass, I will not suggest you to go ahead and start solving 50 different problems around it, right? You will find that, like, I have tried to pick like earliest possible problems, but you see that I could find the problem that was asked in 2022. I could not find, like, the source I had in that, I could not find the problem which was asked last year, last to last year, last to last year, right? But you see that before 2022 is what was asked in 2020. So before 2022 is what asked in 2020. So you see that it is not very frequent, right? So if you have not covered it, this chapter cannot guarantee you 4 marks. This chapter cannot guarantee you 4 marks, right? So if you have not covered it, you may consider dropping the center of mass chapter, right? Or keep it for the last, right? But I'll tell you, like, whenever you go for the NEET exam, every chapter, like, there should be a minimum behind every chapter that you have covered, right? There should be a minimum of every chapter that you have covered, right? Don't leave the chapter in the entirety, right? Keep whatever the board level knowledge you have, right? Just solve few basic questions, right? Just look at those basic questions, and that's that, right? Like for this chapter, if you have not seen it, if you have not solved it multiple times, then there is no point in solving it right now, because it is not a high yielding chapter. So center of mass, you can do simple thing, just look at basic formulas and just keep those in your brain. Just look at few basic solved example, that's it, right? But in the previous chapter, whatever formulas I told you, whatever ideas I told you in the rotation, at least do these things, right? That is going to be very, very helpful for you, right? So that's pretty much everything about this class, my dear kids. I hope this class added a value in your preparation journey. And just look at these 50 questions. I'll be sharing it with you as well, right? Through the link given in the description. And now I'll say tata and bye-bye. And I'll see you there in the next class. Till then, take care. Bye-bye.